today to the next day of the conference. Let me say a few words about today's agenda. Today, now we will have a keynote session with two well-known researchers with their contributions. And next we will have workshop. After that, we will have two technical sessions. At this moment, I would like to say my appreciation to our keynote speakers. Firstly, it is not a random selection. It was too hard to invite them in one place in one period of time. And their contributions, are well deserved and recognized. Yesterday you saw 3 presentations. Today we are staying on 2 presentations. But today's presentations are very interesting and within one scope. I am happy to introduce the first keynote speaker, Professor Jinyang from Shanghai Jiao Tong University, Republic of China. He will focus on the machining of composite metal stacks, challenges, principles, and solutions. The stage is yours.
Well, thank you. So, firstly, it's my great pleasure to make a presentation here for the very interesting conference. I also thank you, my friend, the chairman Vedani, for the kind invitation. My name is Jinyang. I coming from Shanghai Jiao Tong University. So today I would like to talk about the machining, okay? The machining for the aerospace commodity parts. So in my report, I will make a very brief summary for the key challenges encountered for the high performance machining of the composite mechanical stacks. So why I raise this topics? Because currently the engineers, they are seeking the use of very light and high performance components favoring the energy saving to reduce the carbon oxidation emissions. So in my topic, firstly I will introduce the current challenges, and afterward I will introduce the fundamental the cutting principles. This means how we can observe the machining behavior and how we can make some advanced cutting tools or advanced manufacturing technologies. So I'm currently the head of the research group for the intelligent manufacturing and the surface technology, okay? And below I will list some international journals that I welcome you for the manuscript submissions. So at the end of my report, I will show more details. Before starting my lectures, I would like to make a brief introduction of my university. So the university is named the Shanghai Jiao Tong University. This is the most, I think it's the most famous engineering university in China. So the university was established in 1896, okay? So it has represented the most reputable college in China. And the location for the university is at the, not at the center, okay? The city center is probably is here. So the campus is far away from the city center. And the university have a various disciplinary. Probably we have 5 schools concerning the investigation for the science, okay? And we have 8 engineering colleges, and I'm currently working in the School of Mechanical Engineering. So I will show more details concerning how does the university, the school works. And apart from the engineering science, we have also some international joint schools, okay? For example, we have some collaboration with the University of Michigan. So we have the UMSJTU Joint Institute. And we have also some collaboration with the Paris Tech, okay? Now we call it as the SJTU, the Paris Energy Institute of Technology. And we also have some humanities and social science. and as well as the knife medical science. The next one, I would like to introduce my school, okay? I'm working in the School of Mechanical Engineering. So the school is established in the 1913, okay? This is for the inception year. And and currently we have passed about 100 years. So it has a lot of excellent graduations. The next one, I will show you some famous alumni or professors who have been the rector or the president or the chairperson of the university. For example, we currently have the Professor Lin Zhongqing, okay, he has finished his rector position of the HTU. And we have also over 57,000 alumni from the School of Mechanical Engineering. And here I should emphasize that among all these graduations, we have about 50 members, the 50 academic members for the Chinese Academy of Engineering or the Chinese Academy of Science, because they have ever studied in the School of Mechanical Engineering. The next one, I would like to make a brief introduction myself. I finished my PhD in Aerospace in France in 2016, and after my graduation, I joined the SGTU, and my current research activities focus on the composite machining, surface texturing. The surface texturing means I will try to find out the advanced functional surface to benefit the surface performance of natural lattice. But today I will not discuss about these topics. The second topic is I will focus on the numerical modeling. This means I try to develop some analytical models and finite element models to identify the machining behavior for the hard-to-cut materials. The next one is for the material processing, because we currently have also conduct some investigations for the additive manufacturing. So we will try to combine the subtraction, the additive manufacturing together, and then sometimes we call it as the hybrid manufacturing technology. So after the previous introduction, I will move to my next, okay? So I will follow this list of table to start my presentation. So in the first chapter, I will highlight the research background for the composite metal machining. This means why we have to carry out some investigations to reveal the underlying mechanisms controlling the subtraction behavior for the composite and metal sandwiches. And in the second chapter, I will talk about the fundamental cutting principles. This means we have carried out some numerical investigations to identify how the chips are separated from the tool-chip interface. And following this subsection, I will talk about some research results concerning the orthogonal cutting. The orthogonal cutting, we have carried out some studies by using the high-speed camera, and then we try to record the chip separations. And then we will try to compare the numerical inspections with the experimental findings to validate the numerical results. And next thing, I will introduce the twisted drilling. So the twisted drilling represents the most used hole-making operations to create boreholes for the composite parts or for the mechanical alloys. So after the section 2, I will talk about some potential solutions for the high-performance drilling. The high-performance drilling signifies we have to increase the surface performance of the cut surface, but we have also minimized the formation for the damages or defects. So we will introduce some advanced hole-making technologies. For example, I will introduce the vibration-assisted drilling. So in this study, we have developed a low-frequency vibration assisted drilling. We have introduced the vibration for the tool tips, and then the cutting tools, they will go forward and then return back. This means the drilling operations will be totally changed into the interrupter or intermittent contact. So we can greatly reduce the temperature as well as the machining forces. And following the vibration-assisted drilling, we will try to verify whether the MQ, the minimum quantity duplication, can benefit the surface quality improvement for the composite, the mantle stacks or not. So we will carry out some investigations. And eventually I will draw some key conclusions, and I also point out the future perspectives for the next year's research directions. Okay, so the first part, I will introduce the fundamental background and the key challenges encountered in the machining of composite mantles. So the inception for the composite materials has passed, I think, over several, about 100 years or more than that. The composite signifies the combinations of two or more constituents that will involving the reinforcing fibers, okay? Reinforcing fibers, and then the reinforcing fibers that will be implicated with the polymer matrix. So we call this type of materials as the fiber reinforced composite laminates. So the key rules for the reinforcing fibers aims to bound the fibers aim to provide the key properties of the overall composite part. But we have paid more attention for the polymers, okay? The polymers, they can provide the rules to, for example, to bond the neighboring carbon fibers together, they transfer the mechanical nodes, or they can protect the fiber from the environmental damages. But the combination of the two constitute together, this one that will result in a very higher extent or higher degree for the anisotropy. So it will result in a very serious machining problems. For example, if we look at the behavior for the reinforcing fibers, the fibers that basically shows the high abrasiveness, which means they will result in a higher level of tool wear. And also they can entail the chip separation for the brittle fracture. This means they will result in the powdery chips or the dust. And with respect to the matrix polymers, they will show a very poor thermal conductivity. So it is not very beneficial for the heat dissipations, and it will cause a high temperature accumulated at the tool chip interface. The low elastic modulus as well as the low threshold of the thermal damages. So the combination of the two phases together, they will result in anisotropic machinability. But even though the composite parts, they have some challenges for the machining, but they also have been extensively utilized in various industrial fields, okay? For example, we can see some application cases for the wind, the energy-related fields, like the wind power industry. And especially if we look at the aerospace industry, for the new generation, the Boeing 787, the Dreamliner, or even the Airbus 380. And most of these critical parts, they are fabricated by the composite parts. And if we look at the high-performance cars, fundamentally, the frame for the critical parts, they can be fabricated by the carbon fiber or the glass fiber reinforced polymers. And we can also see their applications in the energy or in electronics. For the laptops, okay, for the interfaces, we can use the carbon fibers because they can yield a very high specific strength or stiffness. But the idea is why we have to combine the composite parts with a metallic alloy. So this ideas are arising from the mechanical engineers because they are seeking to enhance the mechanical properties. But we also have to try to avoid the individual weakness for the composite parts. For example, the composite parts, they can undergo a very limited temperature. So we should combine the metallic alloys and the composite parts together. And then we can yield an enhanced property and improved structural functions. So if we look at their application cases for the new generation, the Boeing 787 aircraft, so nearly one half of the materials they are made by the CFRP or the hybrid composite stacks. So the use for the hybrid composite stacks that benefits the energy savings as well as the system performance enhancement. So the combination for the CFRP titanium stacks represent the most used hybrid composite stacks in the world. So I will take this one as an example for my investigation and my report. And sometimes if you look at the interface, okay, so this one they will show the microstructures for the cross-sectional area for the titanium alloy, the CFRP, but we have paid more attention to the interface. The interface signifies the region, the linking both the composite parts and the mechanical alloys. And these areas that represent the most vulnerable zones to the cutting-induced damages. Sometimes we have to emphasize that the CFRP laminates are very challenging to cut, okay? But with respect to the titanium alloys will also shows a very poor thermal conductivity as well as a very high chemical affinities. This means they will result in, for example, for the oxidation wear during the cutting tool machining processes. And in sum, we can say that the serious machining problems associated with the machining of the hybrid composite mechanical alloys that will include, for example, the high force generations, the poor surface quality. This means we will include not only the mechanical flaws, but also the composite delamination damages. And finally, it will also result in enhanced tool wear progressions. So we call it as a rapid tool wear. So the idea is why we have to combine the composite part and the titanium alloy together. This means there are tens of thousands of holes for the mechanical assembly. So we have to use the broad connection or the rivet joining to combine the composite part and the titanium alloys together. So we have to make sure that the machine hole they will contain a very high quality without any delamination or any defects. And in this slide, they will show some typical defects following the drilling operations for the hybrid composite stacks. Here we will see there are some delamination, the burrs, splintering, or even the inconsistent of hole diameter. And if we look at the below image, it will show a schematic diagram for the distribution of the cutting-induced damages. For example, we will have some accuracy errors, for example, for the hole size, the roundness, okay? And we have also some inherent damages occurring at the interface zones here. So we look at these images, you will see there are colored zones, delaminations, burrs, or interlayer gaps will take place. So in general, we can make a summary, a very short summary that the industrial background, they have highlighted the importance for the use of composite mantle stacks. But the machining challenges they will include, for example, we still entails a very poor understanding for the mechanisms concerning the machining. And we have also not very efficient machining operations to improve the hole quality. And in the next part, I will introduce some fundamental cutting principles for the composite mantle stacks. So this one, we have carried out some numerical simulations. We just try to simplify the three-dimensional drilling operations as a two-dimensional orthogonal cutting scheme, okay? So in this one, we have simplified the tool geometries, okay? So this one there will signify the combined machining operations at the interface zones. So the interface, we will assume it here, okay? So this one, the A to A regions, they will signify the interface. And then we have also taken into consideration for the drilling sequence. This means we started to drill the composite part first or the titanium part first. So we have to validate their influence. The next one, we will show you some constitutive models concerning how to develop the numerical simulation models via the Abacus software, okay? So we have used the JCE, the Johnson-Cook model, and we have also developed the Hessian criteria. And the most important, we have developed a very accurate model for the interface regions. So we have introduced the creative zones for the interface regions. And then we combine the three models into the Abacus software, and then we can carry out the numerical simulations. But during the numerical simulations, we have make sure that the errors, okay, for the machining responses, they will be controlled within 10%. And then we can say that the numerical models are okay. The next one, we will show some investigations concerning how the micro cracks will be developed following the orthogonal cutting of the hybrid composite stacks. And we will find out that there are some interesting phenomena that will taking place at the interface regions, okay? So when the cutting tools is approaching to cut into the interface regions, the stress concentrations will take place here. And then with the tool advancement, the micro cracks that will develop following the tool advancements. And specifically, we can also try to find out some methods to quantify the populations of the interface denominations, okay? We have selected some nodes at the interface regions, and then we can plot it in a map, okay? And then we will see here, so this region starting from the 1 to 2, this region that signifies the affected interface regions. So this means the interface cutting does not mean the cutting tools has attached the interface zones. And before the cutting tools approaching to the interface, so the affected, the integrated phenomenon has already taken place. So we have paid more attention to these results. And additionally, we are also identifying how the fiber orientations affect the machining output, and especially the surface quality for the hybrid composite stacks. So this figure there will show a comparative results, okay, in terms of the numerical simulations for the fiber orientation of 0 degrees, the fiber orientations of 16 degrees. So here we have compared their disparate surface damages, okay, for the matrix compression, the matrix tensile, the fiber compression, the fibers tensile damages. And then we will find out that by increasing the fiber orientations, they will greatly elevate the extent for the subsurface damages. And specifically, we have also carried out some orthogonal machining. We carry out the machining on a 5-axis CNC machine tools. And here we will fix the rotation for the spindle, okay? The spindle, they will follow only a horizontal movement. And then we will try to use a high-speed camera. This camera is in front of the workpiece. We try to just to record the dynamic chip separations. And we have also utilized the keystone and the dynamometer, okay, to record the machining forces. So the below tables that will show the details for the geometrical features of the cutting inserts. Okay, we have tried to verify the cutting speed, the feed rate, and then we try to how the process parameters will influence the machining quality for the hybrid composite stacks. So the next slide that will present some interesting images concerning the orthogonal cutting, which are recorded by the high-speed cameras. So we will find out that there are some interesting phenomena. Sorry, for example, here, this one that will signify we will carry out the cutting sequence from the sapphire to titanium, okay? And the below 3 images that will represent the machining operations from titanium to sapphire. So we try to make a comparison. So from these images, we can see very carefully that if we carry out the machining from sapphire to titanium, and then we will yield a very excellent quality for the interface regions, okay? But by contrast, if we try to cut the titanium firstly, then the titanium chips, they will try to adhere on the tool work face. And this phenomenon, they will replace the tool edges for the further chip removal. So here it will result in a severe delamination. Splintering will take place at the interface regions. And more importantly, and if we try to, for example, we try to increase the fiber orientations, okay? We try to fiber orientations. We just deal with the fiber orientation of 19 degrees, okay, for this one. So we will find out that increasing the fiber orientation will definitely increase the severity of the interface damages. Nextly, we have also carried out some twist drilling. The twist drilling means we use a standard twist drill to finalize the hole making operations. So this one, we will entail the use of a titanium nitrogen coated tool, okay? The cutting tools, they will entail a point angle of 140 degrees and a helix angle of 27.2 degrees. But here we have emphasized that both the CFRP laminate and the titanium alloy, they will have the identical thickness, okay, of 4 millimeter. And here we have also paid attention that both the layers, we have used the adhesive, the glues to adhesive the two parts together, okay? And then we will try to carry out the hole making. So the next one, we will present some interesting results concerning the variations of the process parameters and only cutting forces, okay? So if we look at this, the two images, okay, they will show the influence arising from the different machining sequence, okay, the machining sequence. And it is very interesting to find out that if we drilling from the titanium to CFRP, okay, this means the blue colored line, okay, they will signify the titanium to CFRP, and it can yield a minimum, a lower magnitude for the thrust force. And if we look at the delamination factors, okay, and we will find out that increasing the feeder rate will greatly increase the extent for the delamination damages. And also, we can also point out that the cutting from the CFRP to titanium promotes a lower delamination extent compared to the titanium to CFRP cutting sequence. The next thing, we have also tried to characterize the surface morphologies of the machined surface, okay? We will present some results for the three-dimensional topographies of the stack holes. So we will find out that this one, they will signify the interface regions, okay? The interface regions, they will present some critical damages. But here, we will try to find out that increasing the feeder rate, this means we have to increase the chipper volume, okay, the chipper volume. So the machining forces will be elevated significantly, and as a consequence, it will result in a higher level for the subsurface damages. And the next thing, we have also characterized the surface morphology, so the SEM, the scanning electron microscopy, okay? So here we just to compare the results concerning the two cutting sequence, okay? So we will find out that if we cutting from the CFRP to titanium, it will result in a very severe composite damages. For example, the surface cavities because of the matrix loss, okay? The interlayer delamination damages will take place. And if we look at the results obtained from the titanium to CFRP, the sequence, okay, and basically we can greatly improve the surface quality compared to this one. The part 3, I will introduce some solutions for the high performance drilling of the composite mantle stacks. But I should just expedite my speeches, okay? I have very limited time. So the first advanced machining technology is named as the no vibration assisted drilling. So this is a CNC, the 5-axis machine tools, okay? We have introduced the rings, the flagger rings, the roller cages, the rulers, the sine rings to generate the vibrations of the cutting tools. And then the signals that will try to transfer to the drill bit, okay? So the drill bit, they will have an interrupt contact between the tool edges and the workpieces. The next thing we have also introduced try to record the temperature. We have built some models, for example, for the thermocouples, okay, embedded inside of the drill hole, and then to calculate the temperature, the real temperature. And then we will try to make comparisons. For example, so this slide that will present the three results. The first one that will present from the conventional drilling, okay? This one is for the vibration without the forced air cooling. But the next one, we combined the vibration together with the forced air cooling, so we will see that the third solution, they yield the minimum, the drilling temperature compared to the other tools. And additionally, if we look at the drilling temperatures, okay, for example, for the drilling temperatures, we can see that the introduction for the vibrating assisted drilling, okay, this one and this one, they can yield a very small value for the cutting temperature. And even though we look at the surface quality, so this one, the first one, they will represent the results obtained from the low frequency vibration assisted drilling. So the machine surface are much better compared to the conventional drilling, okay? The next one, I will introduce the minimum quantity lubrication drilling technologies. This means we try to introduce the cutting fluid, okay, inside of the drill hole, and then try to elevate the temperature. And then we will look at whether the use for the MQ can benefit the surface improvement of the stack or not. The next one, I will show you some results, okay? This one, they will present the results between the MQ conditions and the dry conditions. But it is very interesting to find out that, for example, if we look at the right top image, okay, this one is for the denomination factors. But it is very interesting to find out that the use for the MQ conditions, they will increase the denominations. So this is a very unacceptable effect. But the problem, I think, is arising from the porous states for the polymers. This means the introduction for the cutting fluid, this one will make the powdery complete chips very challenging for ejection. So that's why you will see there is enlargement, any elevation for the denomination factors. But if we look at the results from the bursts, okay, the burst is for the titanium alloys. So you can see that it is very clear that the use for the MQ condition can greatly reduce the burr formation for the metallic alloys. Very clearly here. Nextly, if we look at the accuracy, the accuracy for the hole diameters, okay, we just look at these images. So this one, you will find out that the use for the MQ conditions, they can create a little bit constant hole diameters compared to the conventional, the non or the dry cutting conditions. And obviously, we can also find their effects for the tool wear, okay? So the use for the MQ, they can reduce the built-up edges. It is very clear for the titanium machinings. And if we look at the cylindricity errors, okay, this one you will see the titaniums, they will show a very lower the cylindricity error compared to the CFRP. So the next thing I will make a short conclusions and perspectives. So in the future, I think we have to firstly optimize the tool geometries, the coating materials that match well with the machinability of the hybrid complete stacks. And we have also developed more cost-effective strategies, developed some advanced manufacturing technologies. For example, we have the clean manufacturing, green machining, or some non-traditional machining for the hybrid manufacturing operations to solve the problems. This one is for a list of relevant publications. Acknowledgements, the cover papers, I will quickly pass it, okay? So the first journal is named the International Journal of Precision Technology. So you will have some manuscripts concerning the precision themes, okay? You are welcome to submit to this journal. The Journal of Coating Science and Technology is mainly concerning the use of coatings, okay? The last one is for the product sound quality. This means for the vibration, the noise control. So you have some interesting papers. You are welcome. So that's all. Thank you very much for your attention.
Thank you very much for wonderful presentation. Personally, I am impressed with the number of results and beautiful presentation. It was really great. Thank you very much.
Yeah, you are welcome.
We are a little bit out of time, but if someone wants to ask questions, please. Yeah, Professor Frolov from Zaporizhzhia Polytechnic, please.
I'd like to ask if there any influence of vibration on reliability of the drills, or did you investigate it or not?
You mean the vibration for the cutting tool?
Cutting tool, or its reliability?
Yes, it is a reality because we have developed systems. And the vibration frequency is lower than 20 kilohertz. This means that the cutting tool, they will vibrate very small. You cannot identify by your eyesight. And we have some company. We have some company in China, and then we collaborate to develop these systems. So we have developed these systems because we have combined this system with our machine tool. And then we developed a specific tool holder. The tool holder, they will fix the cutting tool, okay? And then the vibrations, we have also a computer to control the vibration systems. We can change the amplitude, okay? But the frequency, we cannot change it, the frequency. Yeah, it's fixed.
Thank you.
Okay, thank you for your answer. Thank you for your question. Okay, I also have some questions, but I think I will move it to the coffee break. Thank you very much once again.
Yes, you're welcome.
This is all my appreciation. Thank you very much.
And also some appreciation. Now I would like to invite our second keynote speaker, Professor Andrea Batako, came to us from United Kingdom. His research has the title as now will be presented on the slide. Please help me. Yes, Professor Batako, please, the stage is yours.
Thank you.
Good morning, everyone.
Hello.
All right, it's an honor to be with you here. But first of all, I would like to do something different. And that is to appreciate that we are living in a very fragile society. The world is very fragile, and the peace is difficult to find. We are here, we had breakfast, we wake up, some people do not wake up somewhere elsewhere, some people do not have their breakfast at all. And some people are in the war zone, some people are scared that in the next minute a bomb will fall on them. But we are here in peaceful, enjoying ourselves. I would like to call you for 15-20 seconds silence into those who give their life and those who are fighting today all over the world, trying to keep peace for us to be here. Please join me in a few seconds in silence for those who are in war in Ukraine or elsewhere around the world. Please, silence for them. Thank you. I would like also to express that I'm coming from Liverpool, and Liverpool is a big supporter of Ukraine. Last year, Liverpool hosted the Eurovision on behalf of Ukraine. And I was there at the opening ceremony. I was one of the invited people. And I'm here really to support this conference because as some people were surprised that I'm speaking Russian, I spent 15 years in Ukraine. 15 years I live in Zaporozhye. Therefore, this conference is very important for me, and that's why I'm here. This is what we're doing in Liverpool to support Ukraine. So we are a big fan of Liverpool, of Ukraine. So, I'm coming from Liverpool. Here is some pictures that you would like to see about Liverpool, but it's not a big city. It's just a small one, but with a big heart. If you come to Liverpool, you will see everything. Liverpool lives to tell the story of the people of the world, whether you're talking about the Titanics or you're talking about Jaguar Land Rover, the technologies there, the shipyard. You come there, you live the life. But Liverpool is one city, one world, one culture. Everything is incorporated. If you go to London, you see the African on one side, the Indian on one side, the Chinese on the other side. But when we come to Liverpool, everything is mixed, one society. So if you want to see, you can see from whether you're looking for the Indian culture, African culture, or Brazilian culture, Chinese culture, you come and find it in Liverpool. And you're welcome to come and join us. And it's a very welcome city. Liverpool is also a city of football, sport. You got Liverpool, you got Everton, and then just in 45 minutes, you have Manchester United, Manchester City, and wherever you want in terms of sports, you will find it. I come from Liverpool John Moore University, and last year we celebrated 200 years of this small university. We have 20,000 students, 300 staff. And I was talking to somebody yesterday, telling him that in terms of research, Liverpool John Moore is very research intensive. And we sometimes rank, for example, my Institute of General Engineering Research, every 4 or 5 years we collect our key research and send it to the government to classify and grade. So we do classify ourselves sometimes at the same level of Oxford, Cambridge, in terms of research output. Currently, our research, if you can see over there, is 96% of our research is classified like world-leading or international excellence. Whether you take in astrophysics, we are one of the leaders. Taking engineering, we are part of it. We manufacture and deliver, the telescope. Our robotic telescope can be controlled from internet if you buy at the time. You can do it. We deliver, and before COVID, we delivered 2 of these telescopes to China. So designing manufacturers, I work on the gentleman, Jiangsu just mentioned the manufacturing aspect. We manufacture I work on you have the telescope and the light comes through the hole to the mirror. So I work on the system that holds that mirror to be able to capture and direct the light to the center. So that is a short introduction, and I would like to thank the previous speaker who actually was doing what I'm doing. But I'm really happy that he was here, and then he introduced the system, he introduced some issues that we all have, but I will try to elaborate a bit further and come with more solutions in terms of machine tool design. So he used the existing machine. I will show how we can design the machine to be able to solve the same problem. And the challenges are there. And he has shown you some of the problems. I have here some of the, how you call it, those composites that are really challenging. But I work with a big company, so please don't take photos from here down. Don't take photos because my company will hang me. Because I signed that I should not show it everywhere. That's why I did not email it. We have here. He talk about the CFRP. I'm talking about more advanced composites. And they are here. You can come and have a look how challenging they are to machine. So I brought one of them for you to take a look. So I'm conscious of the time. Before I do anything, whatever I talk here does not belong to me. The knowledge does not belong to me. I borrowed from you, talking to people. That's why I talk a lot. That's how I get the knowledge from people, right? The knowledge I presented is from my students and my teachers. From those I borrow that knowledge. It does not belong to me. If somebody claims he has something, we all learn by talking to people, by taking their ideas and improving them. So I would like to thank my students and my teachers. Those are those who give me the knowledge I'm sharing with you today. So metals, materials. So as we look at the materials, they go all the way from whether you're talking about wood or you're talking about polymers or steels or ceramics. Now, when you mix them, you are the interface here, you have something called composite because it's composition of several elements. Now, the composite existed 100,000 years ago. Until today, in a village, in a remote village in Africa, we mix the stack of hairs with the clay to build a house. And now we're talking about composites that existed well before, right? So basically today, is there any material scientist here? Material scientist? Ah, good. So at least one, and another one there. So what do we do with the composite? There are various, very wide range of these composites. You can see them from carbon fiber, depending on what kind of filling you put in, what kind of reinforcement you put in. You have different type of them, even sandwich, and then you can see even the concretes. Now we put fibers in the concrete for building. We put glass into that to increase the forces or the performance of them. True that when you do that, you have a really special material. And the gentleman before me also has the same pictures, right? 50% of the aircraft is made of composite. Why is that so? And he explained because it's light and it has better performance. Now, the demand on the composite goes really, as you can see, the demand over there, and you can see here the turnover. And who are the main consumer is aerospace, and then the automotive industry. You can see the turnover. Now, the challenge is that if you have all of them, why do we need them? As you can see here, the aerospace, that is a rocket nozzle, and here as well, an entry nozzle, re-entry nozzle. And that, when you mix some material, that I will look at them really now. So you see how here, I'll come back to them. So we look why there is such a big challenge into machining them. You see here, so we have particles and we have ceramics. Depending what you do them, you mix all these, you can see the component. And now let's see the hardness. The material themselves, at any stage, you can see yesterday somebody was talking additive manufacturing, and also we had this picture from the gentleman in the middle there. So you can see that we can now mix, there is some now additive manufacturing technology where you can use various components, different metals, and mix them, and then you can build all these fancy things. But the problem is, they will tell you a nice story, but they still have problem of tensile or residual stress in the material. Now, the key point is that when I think I'm missing one slide here. When we use all this technology, additive manufacturing, wire additive manufacturing, for example, here, wire additive manufacturing, when you finish that, how do you go from that to that shiny, or from this to that, or from that to that? The material scientists will create it and people will use it, but no matter what we do, even the pen you're holding, you would think that is a plastic. At certain stage, it has to come through machining. The plastic may be molded through injection molding, but the mold, we have to make that mold by cutting that metal. So that's the challenge to the machining people. So the next is the machining. So as I said, no matter what you do, all the material, whatever we use, will at some stage come to machining. You can see all these fancy shapes and everything, they are at a certain point machined. And this is where the challenge comes to us when we have these ceramics all mixed up into metal matrix and they send it to us to machine. So let's look at the hardness of the materials. So as we see here, on the top range is the diamond. We're talking about the top hardness. The hardest material is the diamond. I have heard that there's a synthetic material now that has been created which is much harder than diamond, but I'm trying to get my hand on it. I can't talk much because I haven't got a lot of knowledge around it. So if we take the top area, which are the diamond, the boron, titanium carbide, tungsten carbide, and chromium and so forth, tungsten, as those that have circles as the most attractive to the material scientists. They then take it and mix it with anything they can get. So if you see, if we go back a bit, if we look here, this is the technical ceramics and the hardness, the young models. The higher the young models, the more challenge we have. So now there's the gentleman mentioned there, he used one part of the cutting tools. Here are various cutting tools, specially designed for composite. And this is a tip, which is a diamond insert. And here are the hardness of the cutting tool and some of them. And we can see clearly that now as the cutting tool hardness is over there and the material to cut is over there, they are almost the same. So we know that as you increase the speed of cutting, the tool life drops, and as you increase the hardness of the material, the machinability drop. They are all the same. So how do we get along with doing that? Now we can see clearly as the material scientists, they take all that, as you can see what they're mixing into the material, which are exactly the materials of the cutting tool. So they put it now into the material and they want to be machined. We all now get into the one zone, which is called difficult to machine. So next is you can see now some of the microstructure of the material to be machined. If we look inside, this is the material to be machined. So zirconium boron is dead hard. You put it in the material to cut. CBN, which is the tip of the tool I showed at the beginning, it is in the material. Silicon carbide is the grinding wheel material. Aluminum oxide, so forth and so on, you mix them. And this is the tool that I have. I don't have anything different to use to be able to machine. As we see inside the inclusions, we see them clearly, their hardness. Okay, so this means that you have a material which is not homogeneous in terms of hardness, which is highly abrasive, and you have the same thing to machine it. So, in the past, we used to have a stone and the knife, and say, okay, you use the stone to sharpen your knife. Today, the material scientists say, no, hang on, you use that knife and cut that stone. Practically impossible. I can see people shaking their hand. So how do we do? Here is an example, personal example. This is cutting a material using an aluminum oxide wheel. Basically, the material stays there, the wheel goes away. A groove inside. So what can we do? This is where we face. I have one friend who actually nearly lost his career, his job, because he couldn't machine a material that had been given to him. For 3 years, the wheel kept breaking up. So, well, can you cut a banana with a banana knife? Well, somebody might need to design it, so I put it there for you. So this is where I am. So I got to cut something with something. Curiosity killed the cat, but curiosity is one of the things that the researcher have to be able to find a way through from most challenging. And through observation, we gain wisdom. So the gentleman over there mentioned the low frequency vibration. This leading exactly to where I'm going. So 15 hertz, he mentioned low frequency. 15 hertz saved my PhD, because when I did my PhD using ultrasonic in drilling rocks, especially in drilling granite, I nearly failed. 2 years I didn't get anything, and finally I said, okay, let's look into vibration, where I put 15 hertz, and with 15 hertz I could see net an improvement in power and an improvement in drilling rates. So that 15 hertz saved my PhD. That's why I'm here talking to you. Otherwise, I wouldn't be here. So then I move further and say, okay, if 15 hertz works, what can I do with it? So the next thing is we develop a simple oscillatory system. And with a piezo stack, we oscillate the system. And I won't go much into detail because Chengsu explain a lot, give a lot of results on that. Similar thing, you can see that when we're putting here is the nickel alloy. Basically, I managed, you mentioned the MQL, managed to cut this material with MQL. No one ever did it because nickel alloy and titanium are really weird material. You need a lot of coolant to be able to make it. As you can see, the force in cutting really, you can see clearly force ratio. You can see that the performance, if you see here, that is a normal cutting, that is a vibration. And everywhere we found that the vibration has better performance. You can see here, true life is better in all aspects. So then we decided, okay, let's go ahead and look at what can we do. So some short simulation, and what shows us here that in vibration, we see that there is no heat going to the part itself. That is the chip, the entire heat goes into the chip. Whereas normal, you have the heat going into the surface, right? So that one is a bit slow because we are looking at the particles on as well. So it's slowed down to see what we're doing. So from that point, we then said, okay, if it's working, let's do something. I then, my background is in machine tools, machine tool design. So I set up to design the first machine tool. The first one didn't work well, and there's the second one. On the second one, as you can see, we managed to achieve a lot. 10 times in productivity and 5 times in energy reduction. However, what happened is that, as you can read clearly there, I blew it up. It's exploded. Yep, exploded because I forget that machine tools have resonance. So you gotta be careful when you want to follow the way I'm doing, be careful with machine tool design. The spindle response is very important. So then I went back to the desk. So we look at the machine tools, and here are a 5-axis machine tool, the spindle response, and another one. What you want to do is to be able to design your low frequency machining, you need to be able to put it where the machine has the highest dynamic stiffness. So when you put your vibration part, frequency, in the area where the spindle has the highest dynamic stiffness, the machine doesn't feel it. Actually, you start increasing the stiffness of the machine. The reason why, when I say that, there's one guy in Netherlands, he has a big book on that. If you take a rope, it's flat. When you start oscillating it, you see that the rope starts standing. You do standing wave. If you do that with the spindle, you increase the stiffness. So what do? We then went on, as you can see, we designed special oscillators, and actually in our system, we can vary whether you want the frequency or you want the amplitude. We look at the machine, we look at the process, and we can change the frequency, we can change the amplitude. It doesn't matter wherever you go. Because in the Zapciu case, your frequency cannot be changed because I won't go to that theory. Because the gentleman see there, or Katarzyna say, you're going to kill us with 150 slides. There's a theory behind. So I won't talk about the theory. The theory will tell you why it works. So that is just showing again various responses and grinding in the milling and CFRP, as you can see. It works. Vibration works. It doesn't matter which material. It works. Why it works? If you invite me next time, I'll tell you. That's another lecture. Because I prepared the lecture for 1 hour, and Vitaly said, no, 30 minutes. So he didn't tell you have exam to pass at the end. So you're going to fail the exam. It's not my problem, it's his problem. Because you can't sit in my lecture without passing my exam. My questions, you remember? So next thing is that, as you can see clearly, the vibration actually works. You can see the better surface, you mentioned that, and you can see the wheel life and tool life, high better tool life, and you can see without vibration we got a lot of holes, but with vibration we stay clean. So then I said, okay, now I have this foundation, let me go ahead and redesign machine. So to redesign the machine, you can see we look at the response of the table, where we hold the workpiece, and we look at its modal response. You can see the frequencies, and then we look at the spindle itself, how its modal responses, and we look at the critical speed of the spindle. When you're designing, you got to look at the critical speed of the spindle, because without the critical speed, you don't know it, you may you can run at that frequency, at that speed, even if there's no vibration. If you run your tool at that frequency, you enter into resonance, everything will fall apart, even if you don't do vibration. That's why my first machine blew up, because I run the machine to the resonance of the wheel speed. In terms of frequency, divide the wheel speed divided by 60, you get that frequency that matched the spindle, and they went into resonance and everything exploded. So that is something you can look at. So, and then as you can see here, we look at it, that is the lowest one, and we find that this one, we have to be careful, because if we run our experiment around that, we may end up having trouble. So this is the machine runs at 10,000 RPM, but based on this calculation, we cannot run the machine above that. So we stop at 8,000 RPM, and then we move into looking the wheel on the spindle and look at the response. And here are the modal responses. As you can see, you can find that frequency. That frequency there was here. We can see it. So then we move into the dynamic stiffness of the system, and we can see clearly that again, as you can see, is the same way. And then we move on into looking at the spindle static stiffness, looking in that, into simulation and all that, and then we move into the machine tool design. This is the structure of the machine as we design it, and this is the actual machine tool currently in place. And there was a Tawakkoli, a specialist in Germany, estimated this machine have a market of more than 1 billion in China alone. As you can see, it's a very high performance machine tool. It has 6 modes. It can do high efficiency deep grinding, creep feed, vibro, and so forth and so on. However, now, if we then took a step further, and that was back 2009 that we designed a machine tool. This machine tool is ready for Industry 4, which was declared in 2011. We had this machine well before that, and that machine, you can see, you have sensor that tells you the power. Based on the power, you can predict the temperature in the cutting zone. Knowing the cutting zone, you can back up, or you can speed your machining process because you don't want the thermal damage of the surface. He mentioned the term the damage. So you don't want the damage, but because you have extra power and extra material to be removed, and you know the power currently, you can increase in cut roughly and then back up and finish without damaging the surface of the machine, the parts. So it also has some simulation there. And when I designed the machine tool manufacturer are self-protective. They won't want you to look at the performance. So here, the machine can talk basically with the operator. If the operator opens the doors or touch something inside, he closes it, the machine will ask several questions and collect the data and has historical data processing. So here are some of the machines. 10 years later, we have key manufacturers like these are DG Motors using ultrasonic, cable using low frequency, and Citizen. I went last month into Birmingham to see the machine tool. Here are the structure of the machine tool. Now I would like to close. So whether it is composite, hard or not hard, soft or not soft, vibration is the only way I see will machine all future materials. Okay, at the beginning you saw a sustainable development goals. How do we design? Are our design sustainable? Now let's look at the problem of the composite. If you look here, these are the composites out of service. They are not sustainable. You cannot recycle them. You cannot do anything with them. And Germany is struggling with them. Europe is struggling. America does. Look at the airplane after their life. They end up buried in the soil. Is that sustainable? So we here as engineers are the one who creates all this problem. EV cars are coming, the batteries are not recyclable. So we need to be conscious and mindful when we are designing our process, when we are doing our manufacturing, when we're creating the material. We need to think. The gentleman yesterday talked about circularity. We need to think of it. If there is a hope for a next generation sustainable life, we as engineers and scientists should be that hope. Thank you.
Many thanks for your keynote speech. It's extremely interesting and important, not only in machining, but also in sustainability issue. And any questions?
No.
No questions? Okay, I have a question.
Yeah, go ahead.
Very short, and I will ask you briefly, explain your personal opinion. We know that additive manufacturing is extremely developing, but at the same time, machining provides us with high quality of surface, roughness, accuracy, productivity, as well as cost of machining. What is the future of manufacturing? Where is the point where additive manufacturing and machining meet?
They are already together. Because additive manufacturing cannot get away without machining. You've seen the rocket nozzle I've shown you? Now they're manufacturing them using either wire additive manufacturing or all manufacturing, additive manufacturing. But they cannot get, but so far, the best thing they can get is called net to shape. It's close to the shape, but it needs to be machined. There is no way you can go from additive manufacturing directly. Okay, if it's a propeller or is a trouble or something where the roughness doesn't matter, of course, you go directly. You can manufacture a chair, you can manufacture a house in 3D printing, that's fine. But if you want to put in an engine somewhere where there will be two parts matching together with high precision, you will have to go through machining. I don't see any other way.
Thank you very much.
Thank you.
Professor, thank you very much.
Thanks a lot.
Thank you very much. I am extremely satisfied with these two keynote speeches and hope you too. Now we have a short break. The room will be a little bit modernized for the next our agenda's plan. And so I invite you to the workshop. But your choice will be difficult, I think, because we have two invited lecturers who prepared an interesting tasks for you. So please think about to go to Industrial Agile or Machine Learning. We will start at 11:30. But now coffee break. Enjoy.
New materials, intelligent manufacturing systems, smart mobility, biomedicine and medical technology. These are the main fields in which we pursue research, development and innovation in the Plzen region. Create your future with us. Innovate with us. Our region has a history of innovation. Important trade routes have always led through here. The first book was printed here. The first electric lamp was lit. We've seen dynamic developments in transport and new fields of medicine. Two of the world's leading brands, Škoda and Pilsner Urquell, were created here. We are successfully continuing this tradition. We are a region with traditionally strong industrial players, innovative companies, and major university institutions and successful research centres. But we're not just an industrial region. You can spend your free time wandering through the countryside or visiting historical and industrial monuments. You can be active or relax with great food and great beer. There's something for everyone. Here in the Plzen region, we're involved in materials engineering. Research into metallic materials, 3D printed machine tools, special steels, the research and application of thermal spraying, and new technologies for the forming and heat treatment of metals for mechanical engineering and the automotive and energy industries. For example, if you ever come across a smart window which controls the amount of thermal solar radiation passing through depending on temperature thanks to a special coating, this patent originates from research at our university. Manufacturing, power plants and industry in the Czech Republic and abroad use intelligent control systems designed by engineers from innovative companies from the Plzen region. The university's Research Technology Centre is developing completely new applications for contactless thermal imaging measurement, and not only for industry. Sophisticated computers that are built into medical devices are saving people's lives, and they're also being used in industry, transport and aviation. Smooth running. Let's take a look at another rapidly developing field, smart mobility. But we're not talking about just developing new electric drive systems. This is about a whole range of technological innovations for the operation and management of urban traffic, wireless charging, autonomous systems testing, and transmission development. One leading field we're dedicated to is biomedicine. This focuses on research and development in the fields of organ replacement and regeneration. This includes research into the prevention of viral infections after kidney transplantation, as well as research into antibiotic resistance. Specialist software is helping to diagnose and treat liver cancer as sensitively as possible. Software and diagnostics are also helping to prevent transport, medical, and sports injuries. Create your future with us. Utilize the potential of the Plzen region. In practice, in research, at the university. There will always be innovation. Let's succeed together in the world. Innovate with us. The Plzen region, the best place for innovation.
gonna to do. So if you thought that we will just sit and listen to presentation, etc., it would not be a case, because we are gonna to work today, yeah, all of us, yeah. So Agile workshop, yeah. So what we are gonna to do? I'm gonna to give you a brief introduction of this lovely 1.5 hour what we are gonna to do, and step by step we will proceed with the scope of work what we've got for today. Yeah, I have prepared some handouts for you. Yeah, so with the description of what we plan to do. So, can you please raise your hands? Who is aware with Agile ways of working? Agile. Okay, 3 of you. Okay, great. So we have 4, 2. So we have 10 people. Yeah. So I believe we can form 2 groups. Yeah. So we will be working with the groups. If it's possible, colleagues, if some of you can move, one of you can sit here, and then one of you can sit here. Yeah. So it actually will be fully equipped. Enjoy that. It's up to you.
So do you know where is Vitaly Ivanov?
I don't know where is Vitaly Ivanov. Yeah, maybe if you can. Yeah, but that's fine. Yeah, while we are introducing. But after that, I believe you need to work as a one group. Yeah. So it's a good news. We have enough material for everyone. Yeah. So okay, we have more or less 2 groups. You have heard, yeah, my talk of if you didn't. Of his business processes in your research groups, yeah. If you're developing something within the research, how to set up these ways of working. If you are working in any industries, same you can implement these ways of working. So for today, what I've actually picked. So probably almost all of you are aware with the robotic process automation. Yeah, you have heard about that. Yeah. So and I picked this example to be more close with this industrial part. Yeah, with this robotic process automation development. Yeah. So as you can see in 2 pages, in page number 2 and 3. Yeah. Actually, you can see the setup of robotic process automation and requirements for that. Yeah. So yes. 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 Now it works. So these are the setup what we are going to do. Yeah. So as a robotic process automation, yeah, you can read all of that. Yeah. But there are several main responsibilities what robotic process automation development covers. Yeah, it's a developer for a process owner, business analyst, infrastructure engineer. Yeah, those people who are involved in developing that. Yeah, even if you don't know that, again, I can't switch slides, guys. Ребята, слайды я не могу переключить. Можете? Могу. RPA project manager, RPA change manager, maintenance engineer, and quality assurance specialist. I believe that's it. Yeah? So these are the responsibilities if they're building the robotic process automation setup, yeah, as a whole picture. So, and what we are going to do today? Today, this upcoming 1.5 hours, we will plan to describe the main deliverables from the point of this role, yeah, and create user stories. So these small pieces of work, what we need to do to manage the deliverables within the Agile support. Yeah, is it clear so far? More or less, yeah, more or less. Okay. Now I'm gonna now we will be watching some introduction movie about Agile support. So you will be more on board what we are gonna watch. Yeah? So guys, I need a video, first video about economic value of Agile. So these slides are given to you. No, another one. Another one. Agile based, yes, build and increment, the economical, yeah. Yeah, so if you can start, yes, yeah. Okay, let's watch. There is no sound. There is no sound.
In the past, traditional waterfall methods were used and, to be honest, worked fine for the time. But today's systems have become far more complex and we need a better way to work. Now businesses must deliver continuous value and learn quickly, something.
Yes.
Building enterprise-class software and cyber-physical systems are one of the most complex challenges industries face today. In the past, traditional waterfall methods were used and, to be honest, worked fine for the time. But today's systems have become far more complex and we need a better way to work. Now businesses must deliver continuous value and learn quickly, something traditional waterfall approaches simply don't do. Enter SAFE principle number 4. Build incrementally with fast integrated learning cycles. By developing this way with an ongoing cadence that delivers value in small increments, enterprises can adapt to changing market needs without having to wait months or even years. This box represents a piece of value or feature of the system. The final system will be composed of many pieces of value.
Sorry for this technical issue.
This axis is the passing of time in 2-week increments. In waterfall development, you typically work through stages like requirements, design, implementation, and verification. Then at the end, customers. Let's look at how this works. This box represents a piece of value or feature of the system. The final system will be composed of many pieces of value. On this axis is the passing of time in 2-week increments. In waterfall development, you typically work through stages like requirements, design, implementation, and verification. Then at the end, deliver the system and all of its value. In incremental delivery, however, you start by delivering a small piece of value, only as big as we can build in the first increment. Once it's released, it starts providing value immediately. Additionally, it gives feedback and learning that can be used to inform the next increment of value created in the following iteration. This is where the power of incremental delivery starts to really show. This piece of value doesn't just go away, it continues through the full product life cycle. Then, as you continue to iterate, each piece of value builds on the previous iteration's work, delivering a continuous flow of value to customers as the system is built. And again, not only do your learnings from the previous iteration help inform what to build in the next iteration, each time you release value, it continues through the full life cycle. In the end, the waterfall approach can't compete with the total economic value of incremental delivery, even if everything goes perfectly in the waterfall approach, which we know it never does. The bottom line is waterfall simply can't compete with the economic value of early incremental delivery. Not to mention the fact that it's not just early delivery, it's also delivery with fast and frequent feedback, because you learn as you go. Pivoting as needed, you make the final system better. So you see, this notion of early delivery with fast feedback simply creates a better value proposition.
Is it clear, or we need to watch one more time? Clear. So what's our goal? Our goal is to deliver very frequently, as fast as possible. Instead of waiting for whole cycle to deliver the final product, we just need to build some pieces of functionality step by step. And this is what we try to do with it. I have prepared for you all the setup from which roles we can cover these pieces of credit. Yeah? So probably you're doing that from each of the roles or each of the team members. Actually, it is a different understanding why they need this software. Yeah? So, for example, as you can see, I can't switch on slides, guys. Я не могу переключать слайды. Нет, не работает. Yes, how it works. For example, RPA developer, yeah? So what developer does? Design, develop, maintain RPA solutions. Yeah? Write and test scripts to automate business processes. Integrate RPA tools with existing systems. And many others. Yeah? So, for example, infrastructure. Yeah? If we are implementing robotic process automation, we need to ensure that we have enough infrastructure for that. Yeah? Where it should be installed, yeah? How to host that, etc. It's obvious. Yeah? And there should be engineer, yeah, who is responsible for that. And these are some of the examples of applying infrastructure engineer responsibilities. Set up and maintain a environment infrastructure. Ensure high availability, security, performance. Yeah? Topics about availability, security, it should be secure, it should be secure enough, shouldn't be hard, etc. Yeah? Maintain software licenses. Yeah? We need to ensure that our licenses are updated and configured, etc. Yeah? And these, all of the responsibilities we have to fill. Yeah? There is no doubt about that. Yeah? Okay, great. So I have provided to you some of this list of responsibilities. Yeah? Because or if you have your own from based on your experience, yeah, take it as well. Yes, this is completely fine. Obviously, you can use whatever tools you need, ChatGPT for that, yeah, Google search, whatever. Yeah. So the main is to make our actually backlog of work related to that. Yeah. Are there any questions so far? More or less clear. Yeah. Okay. One sec. Let's move on. Yeah, and now we are coming to the first practical exercise. Yeah, we have built two teams. Yeah, so and I believe, yeah, team, for example, team number one, we can have. You can cover these. Team number one, you can pick these responsibilities. Yeah, RPA developer from this point of view. Yeah, so these are 4 roles. From which point of view you will be creating a backlog. Yeah? Backlog of tasks, of deliverables. Your team, you are responsible for this. Project manager, change manager, RPA, quality assurance, and maintenance engineer. Yeah? So this is your responsibilities. Yeah? Is it clear? Yeah. Okay. Great. Now, next page. Yeah.
This
our is the one. This one? No, all of that. But it's up to you. Just this is just an example. Yeah, when you start working, we will clarify. Yeah, so obviously you don't need to cover everything. So let's go step by step. Sorry, just okay. Yeah, five more minutes for introduction. So the first steps, what you're gonna to do. Yeah. So there is a first tool. What we do, we call it create user stories. So what is the user story? Create a user story. So this is the first what you're gonna to do. User story, informal, general explanation of part of functionality written from the perspective of end user. End user or your key person, from which point of view you want to have that, yeah? So you have it already, RPA developer, or you can pick whatever you want, yeah? RPA developer, business analyst, or QA engineer, etc. So the first step for
as you can see, there is a format, it's mandatory format with this framework, how we are going to perform with that, yeah? So the format of user stories is that as a persona, in your case it will be as a RPA developer, as a RPA project manager, I want to, so they want to do something, they want to have some functionality, yeah? So that helps them to do something, yeah? So this is the format. It's actually standardized, we can say, format in our ways of working, how we write that. Is it clear why do we have this standard for writing user stories? Yeah, because around all the world, yeah, people are working with user stories, and if you are following the same format, it's very clear, understandable for everyone. Yeah, it's clear. Yeah. So there are some examples. Yeah. There are some examples I created for you. You can have a look as this as example, yeah. But obviously, please create your own user stories, yeah. So this is the first task. Briefly, very briefly, we will discuss the next what we need to do after that, yeah. Once you create, I believe we can utilize maybe 10-15 minutes to write this list of the user stories. After that, we will create a backlog. So backlog, this is also another tool or another technique. How do we manage development through the iterations or sprints? Yeah, in that video you've seen, yeah, that instead of having those phases, requirements, analysis, design, development, delivery, and all that stuff, yeah, and after that we are just receiving everything. Our goal is to create iterations or sprint what is delivered from the product roadmap and its requirements. The most important items should be in the top of the backlog, yeah? So we know how to deliver them first, yeah? So in this case, you also need to reflect how do you prioritize this, yeah? So which requirements from your point of view are more important? Developers or testers or project managers or maintenance, and at the same time you have to be smart because there is a dependency between these, yeah? Is it clear for everyone, colleagues, that to make something tested, what is the prerequisite to make something tested? yeah, we need to have something created before, yeah, to test that, yeah. So obviously it might be some dependency between that. We call it prerequisites or dependency. To have something developed, we might need something.
You can keep RPA, robotic process automation. You can decide what you can decide create some software, you do some software development in your life. Yes, we need to cover these roles and responsibilities. Maybe you can, if you can go here, don't be shy. We are here to learn something new. Don't be shy, please. Come here. That's completely fine. I will help you. I'm here to help you as well. What do you know? This is one of these ones.
Okay, for example, I as project manager, I will create a virtual media for students, for example.
You can take this, or if you are comfortable, you can take your digital learning exam. So it's up to you. If you feel comfortable with that class, you take the class. For a while, it's easy because we are just starting with one year. The scope of the class. But if you are comfortable with another topic, please focus on okay, but I will create functionality for that. From your as a team, I want as a dev team, as a student, from fully updated, don't buy.
I'm just, no. I'll just give an example. I want to switch to right. So it could be implemented for any user. Just pick your line. So we will require the code because when you will get a presentation, and you will be talking one point. Yes. You will run the user story. Okay. So your first manager you should try to use point of view of the first and the use case will be making the converting materials for the converting environment. Okay?
Ребят, сделай мне, пожалуйста, таймер. До скольки часу, да? Да. Хорошо, давай 15 минут. Сделай мне таймер на 15 минут на экран, пожалуйста. Просто букву таймер. Буквы таймер 15 минут. Окей.
Okay, so now we user stories.
Quality as manufacturer specialist, IT.
Дальше
New materials, intelligent manufacturing systems, smart mobility, biomedicine and medical technology. These are the main fields in which we pursue research, development and innovation in the Plzen region. Create your future with us. Innovate with us. Our region has a history of innovation. Important trade routes have always led through here. The first book was printed here. The first electric lamp was lit. We've seen dynamic developments in transport and new fields of medicine. Two of the world's leading brands, Skoda and Pilsner Urquell, were created here. We are successfully continuing this tradition. We are a region with traditionally strong industrial players, innovative companies, and major university institutions and successful research centers. But we're not just an industrial region. You can spend your free time wandering through the countryside or visiting historical and industrial monuments. You can be active or relax with great food and great beer. There's something for everyone. Here in the Plzen region, we're involved in materials engineering. Research into metallic materials, 3D printed machine tools, special steels, the research and application of thermal spraying, and new technologies for the forming and heat treatment of metals for mechanical engineering and the automotive and energy industries. For example, if you ever come across a smart window which controls the amount of thermal solar radiation passing through depending on temperature thanks to a special coating, this patent originates from research at our university. Manufacturing, power plants and industry in the Czech Republic and abroad use intelligent control systems designed by engineers from innovative companies from the Plzen region. The university's Research Technology Center is developing completely new applications for contactless thermal imaging measurement, and not only for industry. Sophisticated computers that are built into medical devices are saving people's lives, and they're also being used in industry, transport and aviation. Smooth running. Let's take a look at another rapidly developing field, smart mobility. But we're not talking about just developing new electric drive systems. This is about a whole range of technological innovations for the operation and management of urban traffic, wireless charging, autonomous systems testing, and transmission development. One leading field we're dedicated to is biomedicine. This focuses on research and development in the fields of organ replacement and regeneration. This includes research into the prevention of viral infections after kidney transplantation, as well as research into antibiotic resistance. Specialist software is helping to diagnose and treat liver cancer as sensitively as possible. Software and diagnostics are also helping to prevent transport, medical, and sports injuries. Create your future with us. Utilize the potential of the Plzen region. In practice, in research, at the university. There will always be innovation. Let's succeed together in the world. Innovate with us. The Plzen region, the best place for innovation. New materials, intelligent manufacturing systems, smart mobility, biomedicine and medical technology. These are the main fields in which we pursue research, development and innovation in the Plzen region. Create your future with us. Innovate with us. Our region has a history of innovation. Important trade routes have always led through here. The first book was printed here. The first electric lamp was lit. We've seen dynamic developments in transport and new fields of medicine. Two of the world's leading brands, Škoda and Pilsner Urquell, were created here. We are successfully continuing this tradition. We are a region with traditionally strong industrial players, innovative companies, and major university institutions and successful research centers. But we're not just an industrial region. You can spend your free time wandering through the countryside or visiting historical and industrial monuments. You can be active or relax with great food and great beer. There's something for everyone. Here in the Plzen region, we're involved in materials engineering. Research into metallic materials, 3D printed machine tools, special steels, the research and application of thermal spraying, and new technologies for the forming and heat treatment of metals for mechanical engineering and the automotive and energy industries. For example, if you ever come across a smart window which controls the amount of thermal solar radiation passing through depending on temperature thanks to a special coating, this patent originates from research at our university. Manufacturing, power plants and industry in the Czech Republic and abroad use intelligent control systems designed by engineers from innovative companies from the Plzen region. The university's Research Technology Center is developing completely new applications for contactless thermal imaging measurement, and not only for industry. Sophisticated computers that are built into medical devices are saving people's lives, and they're also being used in industry, transport and aviation. Smooth running. Let's take a look at another rapidly developing field, smart mobility. But we're not talking about just developing new electric drive systems. This is about a whole range of technological innovations for the operation and management of urban traffic, wireless charging, autonomous systems testing, and transmission development. One leading field we're dedicated to is biomedicine. This focuses on research and development in the fields of organ replacement and regeneration. This includes research into the prevention of viral infections after kidney transplantation, as well as research into antibiotic resistance. Specialist software is helping to diagnose and treat liver cancer as sensitively as possible. Software and diagnostics are also helping to prevent transport, medical, and sports injuries. Create your future with us. Utilize the potential of the Plzen region. In practice, in research, at the university. There will always be innovation. Let's succeed together in the world. Innovate with us. The Plzen region, the best place for innovation. New materials, intelligent manufacturing systems, smart mobility, biomedicine and medical technology. These are the main fields in which we pursue research, development and innovation in the Plzen region. Create your future with us. Innovate with us. Our region has a history of innovation. Important trade routes have always led through here. The first book was printed here. The first electric lamp was lit. We've seen dynamic developments in transport and new fields of medicine. Two of the world's leading brands, Škoda and Pilsner Urquell, were created here. We are successfully continuing this tradition. We are a region with traditionally strong industrial players, innovative companies, and major university institutions and successful research centers. But we're not just an industrial region. You can spend your free time wandering through the countryside or visiting historical and industrial monuments. You can be active or relax with great food and great beer. There's something for everyone. Here in the Plzen region, we're involved in materials engineering. Research into metallic materials, 3D printed machine tools, special steels, the research and application of thermal spraying, and new technologies for the forming and heat treatment of metals for mechanical engineering and the automotive and energy industries. For example, if you ever come across a smart window which controls the amount of thermal solar radiation passing through depending on temperature thanks to a special coating, this patent originates from research at our university. Manufacturing, power plants and industry in the Czech Republic and abroad use intelligent control systems designed by engineers from innovative companies from the Plzen region. The university's Research Technology Center is developing completely new applications for contactless thermal imaging measurement, and not only for industry. Sophisticated computers that are built into medical devices are saving people's lives, and they're also being used in industry, transport, and aviation. Smooth running. Let's take a look at another rapidly developing field, smart mobility. But we're not talking about just developing new electric drive systems. This is about a whole range of technological innovations for the operation and management of urban traffic, wireless charging, autonomous systems testing, and transmission development. One leading field we're dedicated to is biomedicine. This focuses on research and development in the fields of organ replacement and regeneration. This includes research into the prevention of viral infections after kidney transplantation, as well as research into antibiotic resistance. Specialist software is helping to diagnose and treat liver cancer as sensitively as possible. Software and diagnostics are also helping to prevent transport, medical, and sports injuries. Create your future with us. Utilize the potential of the Plzen region. In practice, in research, at the university. There will always be innovation. Let's succeed together in the world. Innovate with us. The Plzen region, the best place for innovation.
Laura Badita-Voicu. I'm researcher at National Institute of Research and Development in Mechatronics and Measurement Technique from Bucharest, Romania. I shall present you the paper Tribological testing nanometric coatings used for mechatronic components with increased wear resistance. Before the presentation was working. Okay. Wait for 5 minutes. Okay. Can try to put seconds. So I start my presentation with a short introduction in mechatronics domain and the major challenges of our project. So nowadays, mechatronic is one of the most important types of engineering because the high products that are developed in this engineering is found in a lot of industries and domains, like automotive industry, aviation, military, biomedical, robotics, and audio and video devices. The part that is important in all these mechatronic components is the fact that can be functioning, they can function in some dynamic conditions. This meaning that are supposed in time to some tribological property, tribological phenomena. For example, are supposed to friction that in time will degrade and the components and systems destroy. This takes place by various types of wear. Here I just presented the adhesive, abrasive, corrosion, third body wear. That in the case of some components are combined. This is the main reason why the mechatronic components have to be made by materials that have improved mechanical properties like hardness and increased high mechanical strength. Starting from these problems, in our project, we try to extend the lifetime of mechatronic components that are part of guiding systems. And the research task of the project was to increase the wear resistance using various thin nanostructure films and study the tribological properties of thin layers that come into contact with the surfaces of these types of mechatronic systems, and to investigate the thin layers behavior in real dynamic conditions. In order to realize the objective of the project, we use metallic materials like chromium, titanium, and aluminium. We deposited on four types of stainless steel substrates as thin layers and multi-layers. In this table, you can. Oh, sorry. In this table, you can see the main composition and the principal mechanical and physical properties of this stainless steel. And I won't enter in detail right now. So, okay. What? Okay. No, it's okay. Okay. These layers have been deposited on the mechatronic components of a guiding positioning assembly, which was made of a centrifugal cam in contact with a conical dowel. These have been realized by moving background and forward in a round trip. This in the system that had been created. The experimental methods used in order to deposit the thin layers was the PVD method, respectively electron beam evaporation method. After we had deposited the thin layers, they have been characterized from physical, mechanical, and tribological point of view in order to obtain much more information about the hardness, adhesion, topographic characteristics of these structures. Also, in order to determine the deterioration degree of the components that we have tested and we are interested in, we had measured diameter of the components before and after the test realized in real conditions. Based on what I had presented before, the experimental technology cycle started with the deposition of thin layers on the fourth type of stainless steel substrates, respectively OLC45, Rule 1, C120, and OSC8. This has been deposited by a special system and afterwards characterized using various methods. After characterization of thin layers, two materials that had superior properties have been chosen and deposited on real components that had been parts of that guiding system. After functional testing in real conditions, the layers and the surfaces of the components have been tested, analyzed, in order to determine the measurement, the hardness with a special measurement technique system, in order to determine the adhesion, the surface microgeometry, and the roughness of or other tribological parameters with an atomic force microscope or surface microgeometry laser equipment. Also, two types of systems, respectively the non-contact laser beam scanning measure and the length measuring machine, have been used in order to measure the diameter of the components before and after the functional test, in order to see which is the difference between these values. Okay, after realizing that experimental cycle, we have obtained the following results. First of all, have chromium and aluminum layers with a thickness of 15 nanometers and titanium layers with a thickness of 100 nanometers have been deposited on all types of stainless steel substrates, and also a multi-layer of titanium and aluminum has been deposited. Here are just few examples of the surfaces obtained. And after realizing microscopic okay. I think I don't have to present, yeah? Okay. You can see in here the images that we have obtained, and it is visible that the materials of the layers completely diffuses in the substrate and creates a good connection between these two. This is important because we'll create a strong adherence between it. Okay. As I told you, another way of characterizing the layers has been done by using atomic force microscopy. And here is just an example because we had determined a few tribological parameters like roundness, skewness, or corrosion kurtosis coefficient. But from this, for interest for us was the roundness, and we had obtained the smallest roundness for the titanium layer. Also has been observed that the most uniform thin layers have been deposited on OSC8 steel substrate, and titanium multilayer is more, I think has something, is more uniform when it is deposited on C120 type steel. Okay. The physical and mechanical characteristics of thin films surfaces have been determined, and after a comparative analysis, as you can see in these graphs, have been determined the hardness and the friction coefficient. The main results showed that the chrome layer has the highest hardness, and the titanium layer has the smaller friction coefficient. Also, it's important that the chrome thin layer has the highest adhesion when it is deposited on Rule 1 stainless steel substrate. And in the same time, it detaches most rapidly from the OLC45 substrate. Regarding the detachment moment, in the other cases, titanium layer detaches most rapidly from OSC8 substrate, and aluminum layer and the multi-layer from the C120 stainless steel substrate. After the scratching tests of these layers, it was found, after a characterization at the microscopic level, that the layers present various damages. The main of this being deformation, cracks, some particles that detached from the layer appears and can produce again some other problems with the surfaces. Regarding the tribological properties of these layers, here we have determined the variation of roundness before and after the scratching test. The pointed line is the line of the roundness after the scratching test, and you can see in there that titanium and chromium layers are these two with red and green are the only layers that have roundness reduced. And this demonstrates an increased resistance and a good adhesion in the steel substrates. This was the main reason why we have choose and test as protective layers the materials on mechatronic components in real dynamic conditions. The Rule 1 steel mechatronic components have been chosen and tested before and after the wear test. Before the wear test, roundness and hardness have been determined, and it was found for the calculated values that are presented on the slide that chrome layer has a surface smoother than the titanium layers 1. After wear test by rotation during a maximum period of 3 hours, it was observed that the roundness of titanium layer is higher than the one of the chromium layer. This means that the chromium layer has a more uniform surface, and this is connected with a lower destruction, demonstrating the improved tribological properties and the increased resistance of this type of layer. The diameter of these components after the functional testing has also been reduced, and by measuring it before and after the 3 hours here in the case of titanium and here in the case of chromium, has been observed that mechatronic components coated with a layer of titanium has a removal of a higher layer than the mechatronic components coated with chromium. In conclusion, the most important thing was that these types of thin layers generally can be used in order to increase the resistance of mechatronic components. What it is important in our case is that chromium layer, even if it's thinner than a titanium layer, it is harder and offered us an increased wear resistance in comparison to this. Both materials had the improved the wear resistance of the mechatronic components made of rule stainless steel, and the main conclusion of our study was that chrome thin layer, can increase the hardness and wear resistance in a real dynamic environment, and can be used in the future to increase the lifetime of various components. And this is an important result for our mechatronic applications in order to obtain in the future various systems with superior properties. I would like to thank to our collaborators from the company MGM Star Construct that helped us with the equipment necessary for thin layers depositions, and the colleagues from National Institute for Optoelectronics for the measurement methodology. And thank you very much for your attention.
Questions? I understand it's the better result you have with chrome.
Yes.
Chrome self. What really coefficient of friction? Maybe I don't know. You will see. When we start, the coefficient friction is very big.
No, the friction coefficient in here are for any type each type of stainless steel substrate. Is not the chromium is this one. In the case of OLC, it's true, it has a high value. In the case of rule, this value decreases. In the case of C120, it's smaller. And in the case of OSC, it's somehow between this.
I understand that.
I mean, this is not from the beginning to the end. It's classified on different categories of substrates of the stainless steel.
And what you recommend to take a lower coefficient?
To reduce?
Reduce.
Till now, we made tests just with simple lubricants that are made in, are used generally in our mechatronic systems. Because, but I suppose we could improve, we could decrease the friction coefficient by using some other lubrications. Lubricants, sorry.
Understand. Thank you.
I suppose, but we didn't try, because this system I have presented in here is a system that is made in our institute.
Last question. What LOAD you use when you study coefficient of friction? What is LOAD when what force?
Oh, the force.
When you study.
In the case of friction coefficient, I think it was 8 million Newton, if I remember. Just yes.
It's nanotribology.
Yes. Yeah, this is in the part of.
It's no standard LOAT.
No, it's not a standard one, but we applied these parameters because, as I told you, we are making these types of systems for automotive industry. We have comments from Dacia and Renault, and we are testing this type of components in order to see their receipts.
Nanotribology. Thank you.
Let's say micro.
Thank you so much. We have no time for more questions. Please use the coffee break to put more questions, okay? We need to go to the second speaker. Just a small... No, it's for you. Thank you so much. We are moving forward for the second speaker. The second speaker is Anastasiia Symonova. And you have 15 minutes for the presentation, okay? Thank you so much.
Good afternoon, everyone. My name is Anastasiia Symonova. I presented Kremenchuk-Mikhailo Strogradsky National University, and our research topic, enhancing service life and durability of machining parts through surface plastic deformation. Work of this topic began with request from Notorious. This is famous enterprise for product of aircraft engine and gas turbine installation. They had some issues during process plastic deformation of specific machine part with close geometry and with deformation more than 10%. The press tool matrix lost their surface strengths and as follow destructs. Unfortunately, I can't show this machine part because we have in the agreement with Notorious. So the main challenge was to strengthen surface of the press tool matrix, and without dismantling equipment. And we achieved positive results due to impact friction strengthening with the compact tool in the break between shifts. Additionally, literature review showed used combined process for hardening with added intensive plastic deformation showed great results to give increase hardness and depth of hardness and as I said, the main challenge is hardening surface without dismantling equipment, and the aim of the next step of our research is to explore impact friction hardening with torsion for enhanced surface strength and operation efficiently. Research task: validated the method experimentally, assessed of the impact of alloy, and theoretical justificant. This slide showed a scheme and a brief description of the impact friction with torsion hardening method. The tool operation, the tool disc rotated while pressed against the surface and the part, which moves slowly during processing. This contact hits the surface layer of the part above fast transformation temperature. And we have cooling mechanism, tool design, and shared deformation in this slide. Since the cooperation with Notorious was completed, we offered this approach to local industry, particularly granite which used to product of the hardening layers. First of all, we started our research from theoretical significance. In this slide, you can see the model of the dynamic compression of the surface layer with rotating impact tool. Additionally, was posted the following assumptions. In this slide, this assumption and a theme of theoretical part. This study introduced mathematical model in the detailed calculation are given in the article. And this mathematical model aims at calculating the component of the stiffness force, specifically the focus in the two key force generated through the tool's contact pressure with the machining surface and the circumferential force arising from the rotated and pressing of the tool against the machining surface. Additionally, to determine the thickness of the reinforced line, its mathematical model was built using non-composite plan of the second order. To prove the theoretical study, the hardness and depth of hardness layer were measured with and without additional torsion. In this diagram, we can see result of this measuring, and the current study showcasing and 30% increase is the depth of the reinforced layer with the introduction of at the torsion in the impact friction hardening process. Of course, it's the first step in the investigation, and so we prove the theory, our theory, if we added a new component of the impact friction process, we achieved better results. And and the next step, of course, introduce study microstructure and other parameter of the quality of materials of this process. And conclusion of this research. Thank you very much for your attention.
We have 5 minutes for questions, please.
So I have a question to you. You presented interesting research, and I'd like to know: will you continue your research, and if you will, what it will be next?
Next step, it's maybe a lot of materials, kind of materials, of course, and parameters of materials after this process, not only micro-hardness, but other parameters, because it's only a first step.
Okay, thank you.
Thank you.
More questions, please? Maybe I have one. How do you control the layer of the material that will be hardened, depending on each material?
We used angle shift. I don't know. I don't remember in English. Depth of layer. Depth of layers was created out employing the oblique grinding method. It's
A curve?
A curve, yes.
Okay. How do you draw this curve? It is standard curve for each material?
Yes, it's standard.
Yes?
Yes.
Okay. Thank you so much.
Thank you.
More questions? No? Thank you so much. No pictures?
Thank you. Thank you very much.
Thank you so much. We are moving forward for the next speaker. The next speaker is Naiara Sebbe from Brazil. Please.
Can I? So, hello, good afternoon. My name is Naiara Sebbe. I am from Brazil, but I'm doing my PhD in Portugal at University of Porto in collaboration with Polytechnic of Porto. So, the title of the work is Wear Behavior and Machine Performance in Milling of Inconel 718 of titanium aluminium vanadium nitride and titanium aluminium nitride, titanium aluminium vanadium nitride, coated to a comparative study. So for introduction, the machine is one of the most used processes by companies, so it's always subject to improvement, being the importance of this process. With machining, the milling is one of the most processes that is used in Cornell 718 for being a flexible process which generates parts with good surface finish. In Cornell 718, it's a nickel superalloy. It's known for its superior mechanical properties as high hardness, low thermal conductivity, resistance to corrosion and oxidants. So it's considered a difficult to machine material. And because of this, it's a challenge to machine this type of material. This is used in applications in aeronautical, aerospace, biomedical, and petrochemical industries. Tin coats have been deposited in the substrate of the tools to improve the performance of the milling process. One type of these coatings is the titanium aluminum nitride basis coatings, and that can be doped with elements as the vanadium. The vanadium reduces the friction coefficients and consequently reduces the wear and increases the tool lifespan. Another type that is a multilayer coating, the titanium aluminum nitride and titanium aluminum vanadium nitride, that can avoid crack propagation and increase the oxidation resistance. So, the research aimed to compare the wear behavior and process performance of two coatings doped with vanadium, a monolayer coating that is the titanium aluminum vanadium nitride, and a multilayer coating that is titanium aluminum nitride, titanium aluminum vanadium nitride, deposited by the direct current magnetic sputter when milling Cornell 718. So for research tasks, we have the select milling parameters such as cut length and fit per tooth, analyze the morphology of the coatings in cross-section and surface, measure the machine surface hardness, analyze the wear mechanisms, and compare the behavior of the coatings. So about the materials, as I said, the Inconel 718 was used as the workpiece This was supplied in the form of a round bar with a diameter of 158 millimeters. The rich treatments were solution annealing at 970 degrees, followed by quenching water, and precipitation hardening at 718 degrees for 8 hours, oven cooling at 621 degrees for 8 hours, and air cooling. The tool substrate was tungsten carbide with 6% of cobalt used as a binder. And the coatings, as I said, a monolayer, titanium aluminum vanadium nitride, and a multilayer, titanium aluminum nitride, titanium aluminum vanadium nitride, that was deposited by the DC magneto sputtering. So for the methods, the spiral milling strategy was selected that we can observe in the marks in these figures, and this is the conditions. For cutting speed at 100 meters per minute, we were used for all conditions. Regarding the feed per tooth, the central value was 0.07. This was varied 25% for less, that is 0.0525, and 50% for more, that is 0.105, and two values of cutting length, 5 and 15 meters. The axial depth of cut was about 0.08 millimeters, and the radial depth of cut 4.5 millimeters, that is 75% of the diameter of the tool. So the morphology of the coatings was analyzed by the surface and the cross-section. A cutoff of 0.8 millimeters was used to analyze the machine surface hardness. This was measurements in the radial and tangential directions and calculated the average, and 5 measurements in different areas. This is important to highlight that it can be differences in the center and in the periphery of the piece for being the selection of the milling strategy, so can be differences in the measurements because of the wear. And the characterization of wear mechanisms was analyzed by the scanning electron microscopy and by VB3. So for results, here is the results for the morphology of the cross-section. We can observe a columnar morphology for the both coatings. The first figure is about the titanium aluminum vanadium nitride, the monolayer, and the second is the multilayer, titanium aluminum nitride, titanium aluminum vanadium nitride. This is inclined because the position inside the chamber in the process. And in the surface of the coatings, we can observe the rounded grains. In the multilayer coating, the grains is smaller. This is because of the competitive growth and the alternation of the layers. And these grains is the top of the columns in this structure. So for hardness analysis, here is the graph with the values. In horizontal, we have the conditions of the feed per tooth and the average in the vertical. And in the colors is the conditions of the V indicates the monolayer, MV the multilayers, and the cutting length. So when we observe the results, when we only compare for 5 meters, the increase in hardness, the hardness increase with the increase in feed per tooth. This can be observed in these blue columns. In the orange columns, that is about 5 meters too, we can observe for 100 feet per tooth and 150 feet per tooth. Here, we can't consider the results because we observe a lot of vibration in the machining, and the edge, a factor in the edge of the tool. For 15 meters of the cutting length, the hardness increased, as we can see here, after the crease. This can be explained by the increase in the temperature that generates lubricating phases. So for higher cutting length, we have higher hardness. This can be explained by the more significant abrasive wear and the accumulated wear that was observed during the process. So in general, the tools coated with the monolayer coat presented superior results and performance. This is explained by the several lubricating phases that reduces the friction and improve the machine surface hardness. For the flank wear measurement, the VB3, that is the maximum wear. Here is more evident that the cut length is the parameter with the highest influence when we compare the columns. This is explained by the accumulated wear and the abrasive wear. And for higher feet per tooth, this increases the flank wear. The feet per tooth is related to the chip formation mechanisms. And for higher values of this parameter, this generates more localized wear. In general, the monolayer coatings showed less wear, but this wear, when we analyzed it in the same analysis, this was more developed. The main wear mechanisms were abrasive and adhesive wear. Here we can observe the abrasive wear in a monolayer coating, and here the adhesive wear in a multilayer coating, but this was observed for the both coatings, and the adhesive wear was found on the substrate of the two and on the coating, but in more quantity in the substrate of the two. To conclude, the monolayer and the multilayer coats have a columnar structure, with the grains being smaller in the multilayer coating. The monolayer coat presented better results. The cut length present the most significant influence. Abrasive wear and material adhesion were identified as the wear mechanisms. And for future work, it suggested to analyze the influence of different percentages of vanadium in the coating, as well as compare the behavior of the tools without coatings to observe the benefits of reusing coatings. So the work was carried out within the scope of the project Drahobetskyi, transition to the factory of the filter. And I'd like to thank the ZEP, Filipe, University of Coimbra, and FATEC on that campus. Thank you.
Thank you so much. We have time for some questions, please.
Have you plan to go on your research, but in field of flat milling, not only end? It's for question number one. Yeah. If you agree with this, have you planned to submit your excellent research to, for example, to Brazilian Journal of Mechanical Engineering? Yeah. It's very nice, yes. And that's all, okay. 2 questions, thank you.
No, we are doing only the end milling process, but we are analyzing other coatings, and now we are starting to analyze robotic machining. Yes.
Thank you so much. More questions? Okay, I have a couple of questions. You state that the monolayer coating was a better performance than the multi-layer coating. Is the interface between the layers influencing the results?
I think so.
Yeah?
Yes.
How do you intend to overcome this problem in order to improve the adhesion between the first layer of the coating and the substrate and the position of the second layer and the first one?
No, in the work, I don't know. Here is the titanium nitride coating only to improve the adhesion of the coating. So this is beneficial to the coating. It's here. I don't know if it's, but it's a layer here.
Okay, okay. Thank you so much. More questions? No more questions? Thank you so much again. Okay, now we are moving for the last presentation in this session. I would like to invite our colleague Dmitro Lezic. Thank you so much.
Good afternoon. Dear participants, today I am going to present my second work focused on surface morphology and microstructural features of laser powder bed fused superalloy turbine blades subjected to heat treatment and shot pinion. In shortly, my name is Dmitro Lezic. I am Associate Professor at the Laser System and Advanced Technologies Department of the National Technical University of Ukraine, Igor Sikorsky Kyiv Polytechnic Institute. Also, I am currently postdoc fellow at the Aeronautics Advanced Manufacturing Center of the University of the Basque Country. In particular, this work was implemented with collaboration also Kurdumov Institute for Metal Physics and Motor CZECH. Okay, very briefly, yes, this is my home university. Yesterday I presented here. I work at Igor Sikorsky Kyiv Polytechnic Institute. This university is the largest university of Ukraine, university located in Kyiv. Here you can review the main AVE building. At the moment, I am currently training at the Aeronautics Advanced Manufacturing Center, and today I am involved in laser powder bed fusion technology process. Here you can see me. Sometimes I need to put these special clothes because we work with powder. In particular, now we focus on Inconel 718, and because aeronautics center, and we cope with aviation application. Yes, result. On this slide, you can review quickly metal additive manufacturing techniques. For example, binter jetting. I would recommend you, if you are going to work with a lot of parts, it requires a lot of time and consuming to prepare 3D model and after that optimize parameters. If you would like to work with large size metal parts, it's recommended use to direct energy deposition, for example, laser engineering net shape, or more common laser cladding, for example, can be used for such goal. And if you would like to work with complexly shaped parts, today we work with selective laser melting process, or more common laser powder bed fusion process, or electron beam melting. In particular, we work with selective laser melting. This technology, as compared to the conventional, is promising, but at the same time, it requires a lot of improvement. And today, researchers and manufacturing combine efforts to improve this technology. There are some applications where this technology was integrated, but not so for critical application, what we deal today. In particular, this work focused on studies the influence of combined surface morphology.
materials, intelligent manufacturing systems, smart mobility, biomedicine and medical technology. These are the main fields in which we pursue research, development and innovation in the Plzen region. Create your future with us. Innovate with us. Our region has a history of innovation. Important trade routes have always led through here. The first book was printed here. The first electric lamp was lit. We've seen dynamic developments in transport and new fields of medicine. Two of the world's leading brands, Škoda and Pilsner Urquell, were created here. We are successfully continuing this tradition. We are a region with traditionally strong industrial players, innovative companies, and major university institutions and successful research centers. But we're not just an industrial region. You can spend your free time wandering through the countryside or visiting historical and industrial monuments. You can be active or relax with great food and great beer. There's something for everyone. Here in the Plzen region, we're involved in materials engineering. Research into metallic materials, 3D printed machine tools, special steels, the research and application of thermal spraying, and new technologies for the forming and heat treatment of metals for mechanical engineering and the automotive and energy industries. For example, if you ever come across a smart window which controls the amount of thermal solar radiation passing through depending on temperature thanks to a special coating, this patent originates from research at our university. Manufacturing, power plants and industry in the Czech Republic and abroad use intelligent control systems designed by engineers from innovative companies from the Plzen region. The university's Research Technology Center is developing completely new applications for contactless thermal imaging measurement, and not only for industry. Sophisticated computers that are built into medical devices are saving people's lives, and they're also being used in industry, transport and aviation. Smooth running. Let's take a look at another rapidly developing field, smart mobility. But we're not talking about just developing new electric drive systems. This is about a whole range of technological innovations for the operation and management of urban traffic, wireless charging, autonomous systems testing, and transmission development. One leading field we're dedicated to is biomedicine. This focuses on research and development in the fields of organ replacement and regeneration. This includes research into the prevention of viral infections after kidney transplantation, as well as research into antibiotic resistance. Specialist software is helping to diagnose and treat liver cancer as sensitively as possible. Software and diagnostics are also helping to prevent transport, medical, and sports injuries. Create your future with us. Utilize the potential of the Plzen region. In practice, in research, at the university. There will always be innovation. Let's succeed together in the world. Innovate with us. The Plzen region, the best place for innovation.
6 or 7, sorry. We have 6th presentation, and we're starting from our friend from Poland, Jane, please.
But I don't see my presentation. Well, so now we have, okay. Can I take this microphone? Yes, of course. Oh, it doesn't work, but now it's that. But this presentation is about the dynamic analysis of tennis ball launcher, and the main question will be on the end of this presentation, for what we do that. Because we make some basic analytical analysis of a ball launcher where we use a tennis ball, which is nothing new. But we start thinking to the machine which help a spot training, yes? During the spot training, we must think that new spot training should be much more precise, much more, we must repeat, for example, this training, something like that. We cannot do this in the old way. And of course, during this kind of the training, sport training, we always need 2 persons. When we have a machine, we can use only this, for example, goalkeeper, which is the main person during this training, because this machine will be used probably in the future to train a goalkeeper in the soccer match. Yes? So, basically, we start from that may be our main challenges. We start looking on the machine market about the machine devices which help in this sport training, and we didn't find, we only find one machine which helped during the soccer training, yes, soccer players training, and we find a lot of other machines which are presented on the screen. Also, we find the information in the sport literature, sport magazine, that this training should be much more precise. So we usually try to use smaller ball, so we don't use the ball like soccer ball, which is this machine with this orange head is used to train a soccer player, but not to train a goalkeeper. Yes? So we decide to connect a tennis ball launcher with this machine. The machine which we analyze is similar, but we use smaller ball. And of course, this kind of the machine cannot be connected to the electric. It should be wireless, yes? So we must to use some battery, something like this kind of the source of the energy. So we have we start thinking that we cannot develop this machine on the end. We would like to start our project from that we will find the minimum value of the energy which we need to use during the using of this machine. So we start from the basic equation, Lagrangian equation, second order, which I am going to present. So our machine, right here we see, maybe not here, but see, a kinematic diagram of our machine. How I said before, this is similar with this machine with this orange head. So we have 2 rollers, and on the beginning of our analysis, we make some assumption that our tennis ball, which is in the middle of the screen with this point C, we are not going to put in the spin this ball. So both of this roller on the left and the right side of the screen will have the same rolling speed. Yes. So this was our beginning of our analysis, and also we start looking for some information in the literature. We find information about the friction coefficient between the steel and tennis ball, but we didn't find elastic coefficient of tennis ball, what was for us very, very strange. So we started from friction coefficient is Bx,
of course, and on this screen we didn't see elastic coefficient of this ball, but it will be marked by the letter K. So we start looking for the minimum value of the torque, which is marked by by the sign T. And of course, this is one roller, second roller, and okay, we can go to the next screen. And right here we can see the basic Lagrange equation, second order Lagrangian equation, which we use it in our analysis. Yes, and we formulate our research task. We divide this task on the main task and two subtasks. Yes, sub goals. So we know that we would like to calculate maximum torque and power value in the condition of the analyze, and also we will, to find this value, we need to formulate Lagrangian equation, second, maybe not kind order. This is old version of this presentation. And of course, we need to, when we will have this equation, we see that we need to find this elastic coefficient of this tennis ball. So we start from our methodology from the formulation of this equation, and this is the basic second order equation, Lagrange equation. So we start analyzing this equation. On the left, we have kinematic energy, which are formulated in this this equation right here and right there. Right here we have energy equation derivative by angel. Angel are in the sky, angular. And right here we have a double derivative of also the kinetic energy by the angular velocity. And this was very, very simple. But we start thinking about the key J, where we find the information that right here we have some loss, that we lose potential energy. Right here we lose this energy by a friction. So right here you can see the Bx, this is coefficient friction coefficient, and of course in this equation right here you can find that this is deformation. Deformation of what? Of course the tennis ball, and we didn't find, how I said before, the information about this K letter, which is this factor, and how I said before, Bx equal 0,1. Okay. So after that, when we formulate our equation, we know it that we need to make some kind of the research, material research about the elastic coefficient of this tennis ball. So we use our test machine, which is presented on this, which is illustrated on the screen. Yes, this is MTS machine, and we put our ball, this yellow ball, tennis ball, between two plates and compress this ball to measure how the force changing during the deformation of this ball. During our test, we used 10 balls, yes? And this ball was brand new. We never used it before this ball during our test. Test velocity of our upper plate was 2 millimeters, and the acquisition frequency equal 10 hertz. Yes, so we make some tests, but during our test we use also the used before during the tennis training ball, and we see that this curve, this is of course the curve of the ball which was used before. So today we know that we need to develop our model because we don't know, we didn't make a research about a lot of this research about used earlier balls. So we only use not used before ball, and we calculate average curve, average characteristic, which is presented right here, and we make some linear regression of these results, and we get our K factor, which equal 12,1 Newton per millimeters, yes? And we use this, so right now we know the elastic coefficient of this tennis ball, and we have a possibility to formulate, put this data inside our equation. In this table 1, we have input data of our device, yes? So right here we have some kind of the rotation speed of our rollers, mass of this ball, of the rollers, and the radius, and something like that. So we calculate oh, maybe on the next screen. We maybe not formulate, but on this screen we can see how a value of the torque was changing during the time when we shot our ball. We try to shoot, this was only a theoretical shot, of course, theoretical analysis. When the ball is put on the beginning condition, we have this ball in our machine. So this is, we can see that on the beginning we have the maximum value of the power, and during this shot, of course, this value of the torque, value also of the power, is going down. This value allows us to calculate, of course, the maximum value of the power which we need to put on our rollers, and this is not the final value of the power which we will need during the shooting, during the launching of our ball. All of this analysis allow us to formulate some basic condition of our future project, which we need to go and formulate our project and start our research about that, because this is only preliminary research. But we formulate 4 conclusions, maybe for the next task which we are going to solve. So we need to compare our analytical results with the numerical results. Of course, we need to confirm our results in the natural environment, yes, because we don't, in our equation, we don't have information about the resistance of the air, something like that. And of course, we need to formulate our trajectory, ball flying trajectory, and model should be, how I said before, on the beginning, I say that we don't put in our machine, in our analysis, this ball into the spin. So we know that we need to think about we know how to put this ball into the spin, but the model also should have some possibility to put ball into the spin. And thank you for your attention.
Thank you so much. Jana? No, please, because maybe question. Is anybody here who would like to put questions to our presenter? Oh, thank you.
I have a question. Okay. Maybe I skip the information. This about the big tennis or small tennis, because
we talk about this not on the table tennis with this white ball, but with this yellow ball where we have 2 players, normal players, and they have some net between them, and they play on this
because for
green
me,
grass, something like that.
I think that the surface of for small. But table tennis and the big tennis, it's different, and maybe it will influence on the trajectory.
Yes, I understand, but we only use this ball because they are smaller than normal soccer ball, football ball. Maybe sometimes we say the soccer, sometimes the football, but we try to train. We think about train a goalkeeper during which play in the soccer or the football, yes, not tennis. But because this yellow ball, this yellow tennis ball is much more smaller, he must be much more precise to catch this ball when it is flying, yes? Because the soccer ball is very big.
I see, thank you.
Oh, this will be very hard. I know your question. Okay.
Okay.
I try.
Thank you very much for this presentation. But as you said, the question may be hard. If you are planning to train a soccer, football goalkeeper,
Yeah.
and you are using the tennis ball,
Yeah.
your fundamental setting is not in the range. Why is that? The football, the material used to make the football is fundamentally different from the tennis ball. Second, the pressure in the football is totally different from the condition that you have. So if you are taking the fundamental material properties and the pressure property in a tennis ball to apply to the football, that is totally, I don't think that, maybe you can prove me wrong. It's like comparing a goat and a horse or the donkey and a horse. They are similar, they have 4 legs.
I completely agree with you, but this is not our idea. This is, how I said before, this is idea from the sport magazine that people think about the much more precise training, that they must use smaller ball. And the idea was to use, for example, tennis ball in the sport literature magazine, yes? Yeah. But we didn't see any machine, any device which help people to train goalkeeper with this ball. So this was not our proposition to use tennis ball. We take the information from the sport literature, and Jakub, the second author, he was my student, proposed that we must analyze this machine to make this kind of the project to make this device, something like that.
So do you agree with them? As a researcher, you can put your own view and say, no, I want to do this way.
No, I agree with you that this ball is completely different. Yeah. Trajectory could be completely different, but we didn't find this machine. We find that people need this machine because they write some article in some sport magazine, and we stop this project on some basic analysis what we need to do, how big is the power or something like that, because we start thinking that on the beginning we need to find the maximum value of the power to put some battery. Maybe this is senseless, maybe this is stupid idea. We don't know it, we must check it.
Thank you. We have not a lot of time, so other question maybe after this one. Yes, thank you. Jan,
this
thank
microphone is much better.
Thank you very much. No, Jan. Oh.
Thank you very much.
Thank you very much. So we are moving. Our next presentation from beautiful presenter, Marina Ivanova. Applaudissements.
Good afternoon. My name is Marina, and I'd like to present you my research evaluation of penetration of cutting fluid into the cutting zone during the grinding of rolls. Where is the something? So, as you can understand, I will talk about the rolling mill rolls, and in Ukraine they have the big sizes. There is on which one? No, it's not it. Here is you can see the parameters of such rolls. We will talk about the machining, especially grinding operations of the barrel and the sizes of it from the 0.5 meter and in diameter, and the length will be from 1.5 meter to the 2 meters. According to the requirements of the surface of this barrel, its accuracy quality equal from 6 to 8, and the roughness RA from 0.4 to the 0.6 microns. And these technical requirements, they necessary because depends on them. It influence of the work in these rolls on the rolling mills. When we machined it, grinding, the allowances is presented on that table, which we need to provide machining. And it's necessary when we want to provide such requirements, such requirements, we need to provide good penetration of cutting fluid into the cutting zone, because it helps us to remove the heat from the cutting zone and to improve the quality of machining. And there is the factors which might to influence on the penetration of cutting fluid into the cutting zone between the grinding wheel and the part. They are the scheme of what we use when we're machining. It's also the grinding wheel characteristics as granularity and porosity. Also, it's the condition of the cutting grinding wheel. It's after dressing or maybe greasy. Also can influence the parameters of the grinding wheel. Also machining parameters and the cutting fluid parameters such as flow rate, supply method, how we pour it, or maybe it's under the pressure. When we talk about the grinding rolls, we need to take into account that the contact arc length is big for such operations. It's from the 2 to 6 millimeters, and its influence on the penetration of cutting fluid to the cutting zone. From the other side, the airflow created by the grinding wheel also influence on the penetration because they create the air create the floors which try to remove the cutting fluid from the channels which created on the grinding wheel surface. That's why the research aim for us is to analyze the process of grinding roll of grinding mills with the use of cutting fluid and determine the factors influencing the penetration of cutting fluid into the cutting zone, and on this basis to offer recommendation to increase the degree of penetration on cutting fluid in the cutting zone. The Professor Demidov proposed to estimate the cutting fluid penetration by the fluid flow rate which go directly through in the cutting zone wheel and workpieces, and there is the calculating formula for such evaluation. No? But we call this value of cutting fluid as a useful flow rate and propose to found it as a sum of fluid flow rates through the channels formed between the grains, and how it depends on the parameters width of the equivalent rectangular slots in the channel. It depends also from the arc of length of the grinding wheel and workpiece contact. Also, it depends from the cutting fluid pressure before contact, dynamic viscosity of the cutting fluid, and the velocities of grinding wheel and the workpiece. And there is the initial data for our research. And in the end, we got that the big influence on the penetration has the grid number. So it's the size of size of grids in the grinding wheel. And also it depends on the what stage of machining it is, its grinding modes. So is it preliminary or the final grinding? And in the final grinding, because the cutting depth is less, the penetration is better when if it's preliminary grinding. And here is my conclusion. Have I to read it or not? Yes, so cutting fluid penetration into the contact zone between the grinding wheel and workpiece is a complex hydromechanical process depending on the many factors. The penetration of the coolant occurs due to, among other things, capillary effect using the finest network of capillaries formed in the contact zone between the grinding wheel and the workpiece. Dynamic phenomena accompanying the cutting process on the vibrations of the wheel workpiece and the other elements of the technological system created in the process have a significant influence on the cutting fluid penetration ability. The greatest influence on the penetration ability of cutting fluid into the contact zone of the wheel and workpiece when grinding rolling mills is made by the grid size of the grinding wheel and grinding mode, and it's increased the grid size from 16 to 40. It's possible to achieve an increase in the useful cutting fluid consumption up to 9 times. There is 4 to 4.5 times increase of useful content fluid consumption at the transition from preliminary grinding to its final stage, and when the cutting fluid flow rate supplied to the cutting zone increases by 2 times, the useful flow rate insignificant by 17 to 19 times. And thank you for your attention.
Thanks so much. There are any questions to presenter? Please.
Thank you very much for this presentation. The theoretical asset for calculating the useful flow through the grinding, theoretically, it's agreed that we have to take into consideration the wheel speed. Yeah? Why do we have the wheel speed?
Yes, yes.
Because when the wheel rotates, there is a boundary air layer, which is around the wheel, doesn't allow the water to go back. If you look into CRP proceeding or you go into Scopus, you can find some of the work we did some 15, 20 years ago to calculate the useful flow. But in this case, you consider the grain, right? The grain, because you consider the grain during the grinding, the grain has not the same space, that the same size that you took from the manufacturer, right? Because you have the grain size like that, but when you start machining, they become flat. So that size is gone. Because you took that one, when you start machining, it's worn out and it becomes half or even less. So this means the porosity that you have included in your calculation is a theoretical value. It's not the actual useful flow that will go through the grinding zone. So I will suggest that you revise that formula because it gives you a theoretical value.
This formula was revised by the experiments, and there was the device. We tried to catch the value of liquid what get in the cutting zone. There was the special device which remove the chip from one side, and we catch and measure the volume of the cutting of the fluid what was under the cutting zone, and it was almost the same values.
So how much, if you say that, now how much, what will be the jet speed? Because it's not the volume that is matter, the jet speed.
It was not on jet speed. We pour it not under the pressure. It was.
You're using a shoe nozzle because the nozzle has an aperture, yeah, and the fluid should come through the nozzle, right? So the speed that coming, the jet speed coming from the nozzle, must somehow be proportional to the wheel speed. So are you using a shoe nozzle where the water is taken by the wheel?
My English is broken. Sorry. Yes.
So the next question may be in gala dinner, or no? Because we haven't a lot of time. Okay, agree? So thank you very much.
Thank you very much.
For your excellent.
No.
Thank you, sorry. It's our organization mistake here. Thanks. So, we are moving. The next presentation, Artem Yevtukhov, sorry, please.
Good afternoon. My name is Artem Yevtukhov, and I represent Sumy State University, and the topic of my research is thermodynamic and exergetic analysis of the coolness of mineral fertilizers. Currently, at basic chemical enterprises, mineral fertilizer granules that have passed the granulation and drying stage are cooled to eliminate side reactions that lead to cracking and particle destruction. During the cooling process, the moisture content of the granules decreases as a result of the evaporation of residual moisture, which is caused by physical and chemical changes. As a result, the granules acquire the necessary strength, humidity, and temperature that is, they meet the quality characteristics. Cooling of granules as a very common technological operation is performed in coolers of various types, more often in convective ones. Rotary coolers with one drum or two with parallel loading are bulky and have insufficient heat exchange intensity. Pneumatic tube coolers are used for cooling and simulations transportation of granular materials, but they are characterized by increased air consumption and insufficiently deep cooling of the product. Fluidized bed devices have become the most widespread in mineral fertilizer technology as coolers of granular materials. It is also possible to use mine-type devices with a gravity-fallen layer for cooling granulous materials. To increase the contact time and the separating effect in gas-dispersed flows, lowered contact elements of different configurations allow. Apparatus with a fallen gravity layer includes a cooler with inclined perforated shelves installed along the height of the apparatus with various design parameters. These devices have proven themselves well in cooling and pneumatic classification of granular materials. Active hydrodynamic modes of a granular weighting are implemented in the shelf apparatus at each contact stage, the conditions of which can be easily changed within a wide range of gas flow velocities without changing the design of the apparatus. Due to the active contact of gas jet with particles of materials, shelf devices are quite effective for cooling mineral fertilizer granules. Preliminary analysis shows that the cooling process of mineral fertilizer granules is carried out in convective coolers of three main types: drum, fluidized bed, and gravity shelf coolers. These devices are characterized by various performance characteristics, including cooling efficiency and energy consumption. Thermodynamic and exergy analysis will allow determining the optimality of these parameters. This question is the purpose of this work. To solve this aim, the following problems must be solved. First, compile the methods of thermodynamic and exergetic analysis, determine the main thermodynamic and exergetic parameters for convective coolers. Third, to analyze the results of calculations for the rational choice of the type of coolers. As a criterion for evaluating the product cooling degree in a convective cooler, it is advisable to use a cooling coefficient, which is the ratio of the actually removed heat to the amount of removed heat when the material is completely cooled to the initial temperature of the cooling air. See equation 1. External and internal exergy losses are caused mainly by heat exchange with the environment due to heat losses owing to the thermal insulation of device and heat exchange of the product and cooling air at finite temperature differences. They calculate as question 2 and 3. Не працює. Не фунгує. To calculate efficiency coefficient of exergetic and thermodynamic to the questions, equation 4 and 5 are used. To estimate the share of heat removed from the hot product by air, it is necessary to know the air use consumption heat recovery coefficient, see equation 6. The obtained data on the study of the cooling process of various polydisperse materials, both in laboratory and experimental and industrial units, showed certain advantages of the work of the shelf cooler in comparison with the main types of convective coolers currently used in industry. The dependencies of the product cooling coefficient on the ratio of the water equivalent of the cooling air to the water equivalent of the product, which are shown is a figure, shows the sufficient efficiency of the shelf device in terms of cooling the product with specific cooling air consumption 1.5 2 times less than the specific consumption and area of fluidized bed devices, which work according to the approximate schemes of complete displacement and complete mixing. This is due to the fact the approach to the scheme of full displacement in shelf devices is greater Since the material flow rate is higher and the ratio of the height of the layer moving along the surface of the shelf contact to the length of the device section is smaller. Here, there is no longitudinal mixing, and when the flow of material and the cooling medium cross, the maximum value of the driving force of the process is maintained, which has a positive effect on the cooling efficiency. In the zone of the unloading space, an active mixing mode is implemented, which intensifies the cooling after the driving force has decreased. Reducing the weight of the mixing zone, the weight of unloading space increases the efficiency of cooling. The tabular data shows that despite the rather high values of the cooling, thermal efficiency and recovery coefficients, the exergetic efficiency of the coolers is low, and only for shelf devices, the values of the specified efficiency are approximately the same. The latter is explained by lower exergy losses from the final temperature difference for shelf coolers since the exhaust air is heated in it to higher temperature. And this can be achieved, first of all, in devices that work according to the scheme of ideal displacement. Therefore, higher values of exergetic efficiency will have shelf coolers. Two-stage coolers with a thin fluidized bed have higher values of exergetic efficiency than single-stage ones with thin and high fluidized layers. A thermodynamic and exergy analysis of the main types of coolers for granular mineral fertilizers was carried out. The indicators of typical coolers, drum and fluidized bed, and a promising design of a shelf cooler and compared. It is shown that the shelf cooler has an average cooling coefficient, thermodynamic efficiency, of 0.7 versus 0.6 and 0.3 for a single-stage fluidized bed and drum cooler. Second, it has been determined that the shelf cooler is characterized by an exergy efficiency value that is 50% higher than for a single-stage fluidized bed cooler. Third, that analysis of the technological production stage of phosphorus mineral fertilizers proved it is rational to use a shelf cooler as it provides the lowest exergy losses and the highest thermodynamic and exergy efficiency. Further research should be directed to the exergy assessment of the shelf cooler using production technologies for various granular materials. Thank you very much for your attention. That's all.
Thanks so much, Artem, for your presentation. Have you questions, please? Please. Oh, okay. Two questions to you, Artem.
In your report, you show for us maybe 7 or 6 variants of cooler. Yes? My question, how you this construction you use in your model? Where is your model really construction, really size? Efficiency is this construction is very different, but how you use this construction parameter in your model?
Я зрозумів, так. Це
No, I understand. It's hard question.
We have by experimental research. Як то кажуть, не стільки модель.
Okay, I understand. In your model,
This is not model experiment.
You will not use any geometrical patterns. I recommended for you to study this process with final element method. Метод конечных элементов. Да, смоделировать modeling with final element method. It's very well for your task. In any case, your theory not useful.
Finite element methods may be used for this research.
So, and I have a question because this section is very interesting because mechanical engineering knowledges we can use in many different sides of our life, and your topic is quite specific because it's about the fertilizers. And could you explain the actuality of your topic, why you decided to research it?
Okay.
Thank you.
Ukraine is one of the largest producers of agricultural products in the world. The Sumy region, which I present, is an agricultural region. The efficiency of growing agricultural products is directly related to the efficiency of the fertilizers used, in particular granular fertilizers. It is known that the production of granular fertilizers is a rather energy-consuming process. In the end, we all see that as a result of Russian aggression against Ukraine, the issues of food security and energy efficiency have gained great importance.
Thank you. We have a little time only for one short question if you want. Would you like anybody from here? Thank you. Thank you, Artem.
Thank you.
Okay, good afternoon, dear colleagues. My name is Aurel. I want to present results of my research and research of my colleagues from Lviv Polytechnic National University and Ivano-Frankivsk National Technical University of Oil and Gas. This research is related with the design of the technological roads and machining of functional surfaces of parts in current conditions. Our research has been changed very intensively for last 200 years, and that was converted in some research and technical revolution. Professor Arkadiusz Gola analyzed these problems and current states in this direction yesterday. So the sustainable manufacturing and sustainable machining ensured the requirements of Industry 4.0 or 5.0 is closely related with the solutions of some technological tasks in environment protection, in economic and social areas. On the other hand, technological inheritance, including the technological inheritability as a process and technological heredity as a property is closely related with the solution technological task in all direction of sustainability. The design of technological routes require the development of rational technological chains from the initial blank to final path according to technological inheritability. In traditional techniques, we use the estimated refinement for a calculation of number of cutting methods as a ratio between parameters of blank and path. We can use the accuracy parameters as tolerance or surface parameters as roughness. In function-oriented technologies, we must calculate all estimated refinements according to the certain operational characteristic or reliability indicators of this path, and it takes a lot of time and effort. So the research aim of this of my research is related with the elaboration of a technique of the technological routes planning at machining of the critical paths in different conditions. You can see some research tasks related with the research aim. Research methodology. In traditional technique of development of technological routes planning, it is used the ratio between the regulated parameters of accuracy or surface integrity. But the real technological parameters aren't between the maximum and minimum values of regulated parameters, and obtaining results aren't acceptable. On the other hand, many researchers prefer the research of parameters of surface layer under the material parameters. Is it possible to use the parameters of material for the development of technique for technological routes planning? Why not? For example, macro hardness. But macro hardness is slightly changes from the initial path to from the initial blank to final path. On the other hand, in many research, we use the absolute or medium value to analyze the process degradation of material. Lebedev developed the method of LM hardness and offered to analyze the current structural state of material through derivatives of absolute value of material parameters, including the dispersion of measurement results obtained in identical condition on the identical samples. In Lebedev's opinion, homogeneity is the critical indicator for analyze the process of degradation represented by the Weber law. Lebedev offered the analysis of current state of material using the Weber homogeneity coefficient and coefficient of variation. And LM hardness method is very popular in materials engineering. We used these methods in mechanical engineering and developing the technique for design of technological process planning. In our research, we developed the criteria of material homogeneity and used the indicator of its indicator, including the Weber homogeneity criteria, the coefficient of variation, and some parameters related with Weber homogeneity criteria. technological damageability, the constant of material, and the intensity of growth of the technological damageability. The algorithm of the technological roots you can see on this slide. And the development technique has been tested at chef materials. The weight of the blank is about 330 kilograms, and the Markov hardness of surface layers was controlled by portable tester. And the main feature of this technique is the using about more than 25 measurements of macro hardness for each treatment and the control of parameters of blank and surface. Results. You can see the results obtained using the traditional methods. Criteria is accuracy and the obtained methods. Results obtained by means of traditional methods is close to linear, but the results obtained in the development method changed according to the exponential law, and the parameters change more slowly from the initial blank to the final machining. In number of used parameters in after the each technological path depends on the technological tasks. You can see the Weibull homogeneity coefficient or coefficient of variation to analyze the process of the blank, and you must use all parameters, all 5 parameters, to analyze the current states material after the finish treatment. Okay, and you can see the obtained results, damageability, and main conclusions. The main conclusions: we developed the new techniques to design the technological process planning of surface of critical parts using the LM hardness methods. Another direction of my research is using Markov chains in mechanical engineering, and this technique realized by the or described the system of differential equation of Kolmogorov-Chapmans, and the results of these equations change on the exponential law. And now I try to find a key point between the modeling process using the Markov chains and these techniques. And I think that on the next DSMIE, I will present the results in this direction. An acknowledgement. This research has been conducted with the Lithuanian colleagues from the Kaunas University during previous 2 years. And, thank you for your attention.
Thanks so much, Yaroslav. And anybody here who would like to put a question to Yaroslav? Please, without questions. It's so interesting, no? Thank you. Once more, applaudisement. Moving the next presentation number 5. Yes, Ivan Dekhtyarov. Please, Thank you.
Thank you. Testing. Oh, it's okay. Good afternoon, dear participants conference. I want thanks for the program committee for the opportunity presented my research. The topic of my research is research of static stiffness of flexible fixture for Y-type fork parts. Introduction and major challenges. Today, all of people who connected with production, educational, engineering and social science said about boundaries and challenges of Industry 5.0. Industry 5.0 include highest productivity, national standards such as ISO 9001, using modern technological equipment such as CNC machines and robotics with higher productivity and accuracy for production available, and interdisciplinary approach. Cardan transmission is one of the most component of vehicle, such as in vehicle with rear wheel drive. This cardan transmission is consists of some parts, such as fork type parts. You can see. According to the statistic, the number of parts with complex shape is at least 36%, and among them, forks is 10%. Distribution of the parts of manufacturing engineering labor intensity, complex parts is 24%, and among them, 7% is forks. Aim in the research tasks. The research aim is experimentally determine the static stiffness and prove the possibility of manufacturing Y-type forks in a flexible fixture in one setup, meeting the requirements of the drawing. According to the aim, the following research tasks must be solved, such as, first of all, is to develop a structure of fixture for machining Y-type forks in one step. The second is to research the stress-strain design of the fixture for machining Y-type forks using numerical simulation method. And the third is to perform experimental studies using the novel fixture configuration and compare them with the numerical simulation results. Research methodology. The design of the forks, of Y-type forks, is many variants, such as first variant, second, third, and fourth variant. But all of these forks have main parameters, such as overall dimensions, mass, accuracy of the main holes in the ears, roughness of the holes, and contact surfaces. In this research, we choose fork with a long shank for next research. On this slide, you can see the theoretical workpiece locating scheme. In this scheme, Y-type forks installed on 4 points from the outer cylindrical surfaces. And the points, these 4 points is describes green cones. And clamping of this workpiece is 4 points too, described in red arrows. The machining surfaces, if needs must be on this operation, is holes in the ears and holes in the shank and plane in the ears and plane in shank for this fork. The holes needs drilling and boring steps, and planes of the ears needs 2 stages of milling. First stage is rauk and finishing, and the next stage is finishing milling. The plane of the shank is 1 stage rauk milling is enough. Now you can see 2 generations of this fixture. This first generation fixture was protected, patent of Ukraine, its number you can see. But in this fixture have some problems. And after that we developed the fixture second generation. In comparison, first generation and second generation fixture, we can see that number of parts is 8. Weight is decrease from first generation fixture, and time of setup is decrease too. Comparison of the manufacturing process. This is the typical manufacturing process, and this is the propulsion manufacturing process in developed fixture. In comparison, this process, we can see that machining operation decrease from 5 to 1, setups on operation decrease from 8 to 1, technological equipment such as machines and fixtures decrease from 5 to 1, and time of machining decrease from 22.7 minutes to 10.3 minutes. But is developed fixture must be testing. First of all, we make the numerical simulation. We test the boundary conditions such as fixture support, cutting load, and materials properties. And materials properties from workpiece and properties of fixture elements. Results. The results of numerical simulations showed in this table. Displacement is not exceed the admissible displacement from the drawings, and maximum stresses is not exceed the admissible stresses from materials when this part. Such as some pictures of simulation describes on this slide, such as total deformation, directional deformation from the z-axis, and equivalent stresses for the step drilling out of the hole, diameter 24.5 millimeters in the ear. Steps. To realize the experimental studies, we make the experimental sample fixture. As an experimental sample, Y-type forks was taken from the Cardan shaft from Ruta 25 minibus. This drawing with the main parameters and dimensions showed on this slide. Experimental setup for determined displacement consists of the proposed fixture installed in 3-jaw chuck position 2 on this slide. The displacement fiction on indicators position 6 and forced fiction from mechanical dynamometer, which installed between two mandrels. First mandrel installed in the ear of the fork, and the second mandrel position 3 installed in the main spindle. 3-jaw chuck installed on the table on horizontal mill machine, universal horizontal mill machine. Comparison the results of numerical simulation and experimental results is showed then the highest experimental of natural experimental, but is not exceed the admissible displacement for the drawing, and in relative errors from 4.7% to 13.7% is maximum from this experimental research. Conclusions. Short conclusions is numerical simulation methods have theoretically proven that fixtures with incomplete location can be able the machining accuracy. And the second conclusion is for the first time it was experimentally proven that the proposed fixture design for Y-type forks can be provided the machining accuracy. And in addition, I want to tell you about some experience for staff of the Department of Manufacturing Engineering machines and tools of Sumy State University, such as for cylindrical locating and locating for the plane, and locating fixture for locating levers, for locating fork, ash type fork, and for locating connecting rod. Thank you for attention.
Thank you, Ivan, for your excellent presentation and excellent patterns. And what about questions from who? Maybe? No? Okay, please, one question to you.
Please open, if possible, nine slides. Yes, I don't understand. You use for clamping points 8 position. In this we see only 4.
Locating points 1, 2, 3, 4, and clamping points 1, 2, 3, 4, 2. No, in 4 points. Yeah, in 4 points.
No, okay. Next question. When you study static process, what model you use for modeling? Plastic, elastoplastic?
Elastic.
Elastic, yeah. And 12th slide. I don't understand how is load, how is force by cutting process.
Force is this is force for 3 axes. No, in million process and.
But what direction?
Direction very inconvenient demonstration. This is B force. No, this is red arrows describes ANSYS and not good for C present. This is moment here, and force B. This is cutting load.
It's static force.
Yeah, it's a static force. Yeah.
You don't use any moment. No?
Maybe the next question, maybe during coffee break, sorry, because we have not time only. Thank you. Ivan, thanks. Sorry, our number 6 presenter, please. Alexander Sokolov, presentation number... Sergey Alexander, sorry, Alexander over there, sorry. Please.
Dear colleague, I understand you very tight now, but I tight too. But these results are the best on this day in the world. And so I would like you hear me and see my results. First of all, I would like to tell about our team. I'm sorry. First of all, I would like to present our team. It's they are Professor Assistant Alexander Sokolov, Professor Assistant Sandor Chikas, Assistant Professor, Associate Professor Alexander Khoshovsky, Professor Joseph Sharoshi, and I am Associate Professor Sokolov Sergei. We studied pneumatic artificial muscles and phenomena of these muscles which we studied. It was hysteresis, mechanical hysteresis. Now I would like to talk about what is pneumatic artificial muscle and where they used. No, pneumatic artificial muscle used in soft robotics, flexible surgical instruments, medical equipment, biorobot, rehabilitation robots, and exoskeletations, which is the most important during rehabilitation in military operation conclusions. Не понял? Раз. The main limitation of the wide use of pneumatic artificial muscles are the non-linear characteristics and dependence of the input pressure on the lens and the phenomenon of mechanical hysteresis, reducing the delays in system response. The non-linearity of characteristics due pneumatic artificial muscle parts are made of highly non-linear materials such as flexible rubber or plastic. First, you can see work pneumatic artificial muscles on the slide. Force displacement hysteresis during muscle action mainly occur due to dry friction. We know that there are two approaches to reduce influence on hysteresis, such as I'm sorry. Use advanced model-based control model algorithm and direct hysteresis compensation through adaptive system. We change advanced model-based control algorithm. The aim of our researchers was to demonstrate a new approach. It's our approach based on the use of empirical model to minimize hysteresis. For achieve this aim, we did the following research task. Firstly, we experimentally obtained a hysteresis curve. Secondly, we finally turned the coefficient of 6 proportional integral controllers. About these controllers I talk later. And third, we adjusted the transfer function using correction curve. Research methodology. Study of characteristic of pneumatic muscle we carry out at the University of Szeged on the stand presented on the slide. It consisted of the following components. Data on current position, we measured by position sensor 4. Controller 2 was used to gather information on the current position. The pressure controller regulates the output pressure control of pneumatic muscle 1, by pressure regulator 3. This was our stand. We used laptop. We used laptop for monitoring the pneumatic muscle control process and data processing. The block diagram of the experimental installation is presented on the slide. It is a standard control system which consists from position sensor, controller, and actuator. Also, we used a laptop which used for as a supervisor, control and data acquisition SCADA. The measured and controlled parameters of the installation are presented on this slide. Pressure was changed from 0 to 5 bar. Position and position muscle end was from 0 to 4.5 centimeters, and other parameters you can see. Results, I think it is very interesting because I would like to talk about our results and their processing. The data we obtained on the position of the displacement of the pneumatic artificial muscle end at the various pressure levels with increments set at 0.5 bar intervals during the experiment. I would like to compare these results with slide. You can see as we measure it. We give pressure and measure it The resultant data was used for the construction of the hysteresis curve. The blue curve, blue curve graphs shows the change in the displacement position of the pneumatic artificial muscle end with increasing pressure. Red curve with decreasing pressure. The graph shows that the hysteresis reached up to 8 centimeters, as you can see. It was decided to minimize hysteresis by using advanced experimental model-based control algorithm, as I said. The next step in the methodology required a mathematical approximation of the extension and construction curves. We remained зависимость. Using secondary derivative, we find it four points of this curve. What we do? We take secondary derivative and equal to 0. So we find two корня. Okay. For the construction curve, potential points were 4.3 and 1.6. So we can divide this curve on the three segments, as you can see on the slide. For the extension curve, we find 2 points. It was 4.1 and 1.2. We divided on the 3 segments. It was decided to use six P controllers for each segment. The coefficients of the P controllers were determined by using the MATLAB P turn-up package. P controllers were built based on these coefficients, and the response to the signal is shown on the figures. As a result of the experiments conducted on the movement of the pneumatic muscle, for each P controller, correctional curve were proposed with offset value Y, which depends on the position X. Such setting of the P controllers made it possible to minimize the influence of hysteresis. The average root square error is less than 0.3 millimeter. It's less results in the world now. You can see on the graph.
Okay.
Conclusions.
Shortly, please. Conclusions.
Conclusions. No. In conclusion, I would like to say that the proposed hysteresis minimization method is a promising strategy of controlling pneumatic muscles. It allowed to the reduce of the average root square error to less than 0.3 millimeter. Thank you for your attention.
Thank you so much. Thanks. It was Sergey Sokolov. Thank you very much. We haven't any time for questions, sorry. So it was our last presentation for today. And for Sergey, we have our presentation, our present.
To our session chair number 7, Professor Liliana-Laura. We really appreciate your help and contribution. Thank you very much.
Thank you.
Thank you. Now we are waiting for the end of the online session in the next room. And after a short break, we will start the awards and closing ceremony. Please don't miss from the conference call because it will be interesting. I believe. Thank you.
materials, intelligent manufacturing systems, smart mobility, biomedicine and medical technology. These are the main fields in which we pursue research, development and innovation in the Plzen region. Create your future with us. Innovate with us. Our region has a history of innovation. Important trade routes have always led through here. The first book was printed here. The first electric lamp was lit. We've seen dynamic developments in transport and new fields of medicine. Two of the world's leading brands, Škoda and Pilsner Urquell, were created here. We are successfully continuing this tradition. We are a region with traditionally strong industrial players, innovative companies, and major university institutions and successful research centers. But we're not just an industrial region. You can spend your free time wandering through the countryside or visiting historical and industrial monuments. You can be active or relax with great food and great beer. There's something for everyone. Here in the Plzen region, we're involved in materials engineering. Research into metallic materials, 3D printed machine tools, special steels, the research and application of thermal spraying, and new technologies for the forming and heat treatment of metals for mechanical engineering and the automotive and energy industries. For example, if you ever come across a smart window which controls the amount of thermal solar radiation passing through depending on temperature thanks to a special coating, this patent originates from research at our university. Manufacturing, power plants and industry in the Czech Republic and abroad use intelligent control systems designed by engineers from innovative companies from the Plzen region. The university's Research Technology Center is developing completely new applications for contactless thermal imaging measurement, and not only for industry. Sophisticated computers that are built into medical devices are saving people's lives, and they're also being used in industry, transport and aviation. Smooth running. Let's take a look at another rapidly developing field, smart mobility. But we're not talking about just developing new electric drive systems. This is about a whole range of technological innovations for the operation and management of urban traffic, wireless charging, autonomous systems testing, and transmission development. One leading field we're dedicated to is biomedicine. This focuses on research and development in the fields of organ replacement and regeneration. This includes research into the prevention of viral infections after kidney transplantation, as well as research into antibiotic resistance. Specialist software is helping to diagnose and treat liver cancer as sensitively as possible. Software and diagnostics are also helping to prevent transport, medical, and sports injuries. Create your future with us. Utilize the potential of the Plzen region. In practice, in research, at the university. There will always be innovation. Let's succeed together in the world. Innovate with us. The Plzen region, the best place for innovation.
Dear participants, I will cite the last speaker who said, I understand that you are tired, but we need to complete our agenda, and now, according to it, is awards and closing ceremony. Let me start this session. I promise to be short and brief. Okay. So, yes, thank you. In this session, I will point out on 4 points. The first one, we will make some summarizing and statistics about conference, about DSMIE conference series as a whole. Next, we will announce Best Presentation Awards. Then, we will present the DSMIE 2025, the location, the venue, and sightseeing about it. And after that, we will present the President's Award from the International Association for Technological Development and Innovations for the first time. So the first one is summarizing and statistics, and this conference gathered together 148 contributions. After active peer reviewing process, we selected 83 of them, achieving the acceptance rate 56%. 324 authors from 28 countries contributed to these 2 volumes of our book, and 110 program committee members and invited external reviewers were attracted to the conference. During the conference, during these days, 75 registered participants from 16 countries participated, and thank you very much. The great value of each conference is our participants, and this applause for you. Thank you very much. We are happy to add to our list of keynote speakers 5 more speakers from the world. And now we achieved 36 keynote speakers in our history who presented 15 countries. For the first time, we saw keynote speakers from Norway, China, and United Kingdom. It was not easy to get together all of them here in one room in one period of time, and we are lucky to did it. And we are greatly appreciate that they can share their experience to all of you. Thank you very much. As you can see, some statistics about institutions, and I highly appreciate the Plzen University of Technology in this significant achievement. Also, for the second year in a row, we launched Business to Science session, and I'm happy that speakers from 3 countries contributed, and I believe the results will be in the near future, because business cannot be without science, and science cannot be applied without business. We understand it, and we are initiating this process within the conference. It is great that we also completed DSMIE workshop and DSMIE summer school in virtual mode. Participants gave their feedback, and it is essential for us for future thinking about implementing it to the next editions. I know all of you are waiting for the publications. The first volume will be published next week. At least Springer noticed me about it. The volume 2 will be published a little bit later. But don't worry, it will be published, it will be indexed, as always. Let me remind that we have cooperation with journals and special issues. If you would like to publish papers, you can contact the DSMIE team, and we will establish the direct contact with editorial boards and will help with this. Now, maybe the most interesting part about Best Presentation Award. It was not easy because a lot of interesting and attractive presentations and some discussions were very hot, and participants wanted to present as much as possible. The participants from the hall asked a lot of questions, well, not a lot of questions sometimes, but anyway, we made a decision, and it is based on scientific quality of the research, on the technical background, on the interaction with auditory, because it's important for the researcher in the future. And we selected 3 best presentations. Of course, we are thankful for our session chairs who made their decisions and helped us in this. Personally, I tried to see all presentations. Even this morning, I devoted to YouTube and checked yesterday's presentations that I not visited. Okay, let me announce the first awardee.
Yes, one. Yes, one. I'm assistant.
Yes, thank you very much. Best Presentation Award is proudly presented by the International Association for Technological Development and Innovations to participants from André Pedroso,
Congratulations. Don't let us, please. No. Stay.
Okay, next.
Outside now.
Next one. It's an interesting research in the field of, I think it's in the field between materials and manufacturing, and very important for current society, for current industry. And let me invite to this stage the participant from Romania, Liliana-Laura Badita-Voicu.
Please smile.
This presentation I cannot visit, but I saw the results of evaluation of session chair, and after that I also saw this presentation via online technologies, and it was really interesting and important. Let me invite the participant who represented. Actually, I don't know your nationality, but I really know the affiliation. Unais Said from Free University of Bozen-Balzano.
Thank you very much and congratulations. And the word is yours.
Thank you very much. Both must. I help you.
Thank you very much. As you can see, one more seat is also possible. I will invite the person a little bit later. But now we are going to the next part. Some of you asked me, where is the next event? Should we book tickets right now or, or publications first? Of course, publications first, but you really must know what is the destination. I have a lot of considerations and discussions with different teams, and this spring we agreed the next edition. We agreed the city, we agreed the country, and start working on these arrangements. Let me invite the local chair, co-chair of the DSMIE-2025, Professor Francisco Silva, who will present the next edition of the conference.
Thank you very much.
На экране нету.
Yes. Okay. Good afternoon. Maybe you know me. Some of you already experienced the conference that is organized by my team. So I will talk a little bit about what we intend to do in the next year. Some of you know how it was the FAME conference in last year. So we intend to make our best work in order to go further, to go to the next level in terms of the DSMIE. I would like to present some details of the conference in order to encourage you to go to Porto. Okay.
Next slide, please.
Okay. Okay. Where will DSMIE 2025 be held? In a beautiful city named Porto in Portugal. Okay, this is one of our best landscapes. I hope you enjoyed to experience a good trip and a good stay in Porto in the next year. The local where we are thinking to hold the conference is a foundation, not in the downtown of the city, but in a very calm place, close to the center and with very good access in terms of public transportation and so on. So it will be here. The rooms that we have to offer are, as you can see, very good. Okay, this is the main room. The other rooms are like this and like this. Okay, these are the small ones, and the posters will be exhibited in the foyer. Okay. This is the restaurant of the foundation. So it is here where we can take the lunch and so on. This is one of the main parts of the city. You need to go to Gaia, to the other side of the river, to get this image, but I think it compensates to get this view. Okay, this is very traditional. In June, this place is plenty of people. Okay, so it is difficult to find Portuguese in this place because we have a lot of tourists. Okay, this is the night view of the bridge, the main bridge of the city. This is the Clérigos Tower. It is very typical in the city. You can go to the top and get a good view of all the city. This is the city hall. It is a very good place to stay and to take photos, because now we have Porto in great scale here, so it is a nice place to get photos. This is a traditional landscape of the city where we can take some concerts, some shows and so on. This is the park of the city. It is very close to the place where the conference will be held. So it is nice to go the conference to the city park and get a ride in the park. It is a nice place to take a walk. These are the traditional churches in our city, with the tiles, painted tiles, very traditional in Porto. The internal view of many churches are, as you can see here. This is a modern building in Porto. It's the music house where there are concerts every day. Okay, this is the main room of the music house. The conference is close to the sea. Fame in the last year was close to the river. This time it will be close to the sea. Okay, this is the main view of the sea. You can see the Atlantic Ocean in the background. This is an image of the sea. This is our club, very popular in Europe. So I think if you like football, you know Futebol Clube do Porto. This is the cellars, the port wine cellars, very popular. Okay, I hope you have opportunity to go there and to taste our port wine, because it is impossible to do not consider this hypothesis. And now I would like to show a video. And in the meantime, I would like to say that more than you can see, I think you can feel the people, and the people is very warm. Okay? Hope you have enjoyed the video. The expected program is like this, but joining industrial management, I talked with Vitaly in order to add these points to the next conference. We intend to increase the number of participants, and it will be a good choice to include this topic to the conference. There are many topics. I think one of these topics will be aligned with your expertises. So I hope to have your participation in the next edition of this conference. We will have 4 keynote speeches, at least. About 220 slots for scientific oral communications, so there are place for all. Okay, I hope to get your presence in our conference. 4 or 5 simultaneous sessions. We have 5 rooms available, so I think we can increase the conference to 4 or 5 simultaneous sessions. Poster session and networking sessions. We will use this time the Conf tool to the conference, not the Easy Share, as it is usual, because we are more familiar with the Conf tool, and I think Conf tool is more user-friendly. Okay, so we will use Conf tool. The address, the link is over there, and the link for the conference is the usual. So in 17, we have reception, opening session, 2 keynote speakers, oral sessions, networking session, and welcome dinner. In 18, we have oral sessions, poster session, and port sightseeing. We are studying if we will have a similar sightseeing like in the last year, or if we will make a walking through the city in the downtown. In 19, we have oral presentations, 2 keynote speakers, closing session, Douro River Cruise, and gala dinner, out of the place of the conference. In 20, we have technical tours with a touristic or social program as well. In 23rd, we have the party of the city. Okay, I think it is unforgettable to participate in this party. Okay, I don't know if some of you that were in Portugal. Yes. What can? What can you say about the party? Thank you so much, Katarzyna. Okay, we are expecting to visit the Continental Tires company. Okay, this time we will go to north. In the last year we went to the south. In the next year we will go to the north. This is a very huge plant producing tires for cars. This is Leica. I think everyone knows Leica. This is a very huge plant in Portugal. And it is, I'm not sure, but I think we will get. get the opportunity to visit Airbus Atlantic, where some body structures are produced. But if not, we will visit Tesco or we will visit Bosch. Okay, I think you know the brands. There are huge. They are huge. They are huge plants. I think they are very interesting to visit. After the industrial tour, we will have a visit to the north of Portugal, to typical places in order to increase your knowledge about the Portuguese culture and so on. And maybe we finish our tour in Porto wine cellars. Okay, so in another cellars, but interesting as well. So this is the same. This is the cruise in the river. Maybe this is the sightseeing. And we are planning to take the final gala dinner in this farm. It is very typical. It is in Matosinhos, close to Porto. It is my favorite place. I think it's typical and it will be a good choice. So Portugal is very far away from Russia, okay? So you are safe. You are safe. We are in Porto, in the north of Portugal, okay? We have a very good airport. This airport was classified as one of the best airports in Europe, so it will very good. There are very companies flying to Porto. Vitali, Admi, Ryanair, EasyJet and Vueling as low-cost companies, but there are a lot of choice, so it is easy to reach the Porto airport. And after that, you can take the metro from the airport direct to downtown. It is cheap, about 2 or 3 euros, and it is very easy to reach the center of the city. In terms of publication, we have the plant, the layout of the program. We will have two different ways to publish. We have the proceedings following the usual proceeding, and we will have fast-track submissions of large papers in order to be published in very interesting journals. Okay, I will show the journals in the next slide. If your paper will be rejected for something, you have the opportunity to publish in a last special issue of lecture notes in mechanical engineering that will collect the rejected papers of the fast-track submissions. At the moment, we have the lecture notes in mechanical engineering already ensured. The International Journal of Advanced Manufacturing Technology, the JMMP from MDPI, and in the next week I will try to close the agreement with the mechanics-based design of structure and machines. It is a journal of Taylor and Francis with 4.1 impact factor. So it will be great to have the journal with us. We are trying to get collaboration with other journals in order to increase the possibilities of spread your work. Okay. This is our local team. Some of these faces are here with me. Okay, Naiara is over there, and André Pedroso is here. Okay, so maybe some of you already know some of the people. So José Carlos I think Katarzyna knows, Justina knows, and so on. Vitaly, of course. And there are more people. Raul Campilho is a very high-cited member of our team, and so on. Okay. My team is very good. I'm proud of my team. We will have the support of some companies. Kistler will be present in the conference. I'm trying to get the collaboration of the Kistler in terms of Switzerland to have a keynote speech in the conference. And usually we have the collaboration of the tourism of Portugal and the Polytechnic of Porto, where I'm integrated, and the usual supporters of the conference. So, hope you enjoy the next edition of the DSMIE, and thank you so much for your attention.
Just to sum up, why not? It will be the western location for our conference of series. It is very close to the ocean. It is a beautiful atmosphere. It is fantastic city and hospitality, Portuguese hospitality. October, yes. And also this decision was based on the quality of organizing team who can really do it. And the numbers that you see, 200 participants, is really possible. So book these days in your calendar and see you next year. I understand you are tired, but that's why I will speed up a little bit. So, for the first time, we have launched IITDI President's Award, and this award we established for the outstanding contribution to our member who devoted time for the development of association principles, trying to share it in different ways. And this award was specially designed, and now I would like to present it. It is like a book with the name of the awardee. Not yet? Okay. This award is granted, and this is our sincere appreciation for hard work and dedication. Your contributions have been invaluable invaluable to the International Association for Technological Development and Innovations, and we are grateful for all you do. Specifically, we want to recognize your outstanding work on the DSMIE conference series. Your contribution has been instrumental in achieving our goals and exceeding our members' expectations. We encourage you to keep up the excellent work, and we will continue supporting your growth and development. You are an esteemed member of IITDI, and we deeply value your diligent efforts and commitment. This award is granted to Dr. Justina Trojanovska. I am not surprised. This applause because you are really worth it. And Justina Trojanovska, our member from Science 2019, and this award for you. Can I assist you?
Yes, please.
I just want to say just two sentences. Together, and only together, we can do more for science, technology, engineering, and education. Sława Ukrainie!
Heroям слава. This is a response to these words from Justina in Ukrainian. So this is not the finish. We invite you for the gala dinner. Please remember 7:30 Schweik restaurant. Address is pointed as well as in the detailed agenda. And you have already received this group photo, and it's a great pleasure for us to be with you. And thank you very much. Some few slides about behind the scenes. It was not easy to organize because the conference was both in digital, virtual, and offline versions. And guys, Vladislav and Alexander, where are you? You did a great job. This applause is for you. Thank you very much. Okay, thank you. Some of us was tired, but happy, and also we did a lot of things. Hope you enjoy. Welcome back, and it will be useful for you. They are happy. Thank you very much. It was a really interesting period, and big applause to Milan Edel. Take it. Without you, it cannot be realized. Thank you very much. Thank you. And the last slide for today. Thank you very much for your participation. Looking forward to meeting you next year and see you in the evening. Thank you. The last words to my team, DSMIE team, who helped not during this period of conference dates, during the whole year, because the preparation started 1 year ago and lasted each day, sometimes in the night. And hope you enjoyed it. I think next week we will send you the survey. It will be anonymous, and we want to receive your feedback, true feedback, because we would like to be better and better, and so we will ask you some positive moments and also some critical moments, because we want to be better. And together we can do more for science, technology, engineering, and education. Thank you very much. See you in the evening. Thank you.